start, and then we'll wait for the speakers to join us. Good afternoon and welcome to Boston University. My name is Lou Chitkushev. I'm the Associate Dean for Academic Affairs at Boston University, the Metropolitan College, and it's my honor to welcome you today at the Data Analytics Symposium, which is co-sponsored by IBM and Boston University Metropolitan College. Data analytics is an area of high interest, and especially big data analytics. And over the last decade, but mostly over the last 5 years, it has penetrated in practically all areas of science and industry and applications. It's hard to imagine an area of work or research or interest these days that doesn't deal with analytics. And this has been going on for a while. We know that, for example, in highly quantitative areas like finance, data has been present for centuries. But what is different right now is the accessibility of data, availability online, and also ability to process the data in real time, which usually was not traditionally done. It was usually done post factum. Also, we know in security how that has affected real-time processing of data, and in many other, in first iteration, unrelated areas like marketing or human resources, even education, which is one of the probably areas of high interest for us here at the Boston University. Today, we, thanks to analytics, we have ability not only to record what's going on in our face-to-face and online classes, but also to act while the class is going on based on the data that is being collected. So it really opens analytics, and data analytics opens new horizons in acting or improving performance, and also doing predictive work, which is forecasting and doing forward-looking analysis. So the industry needs are increasing, and also they have to be matched with the demands that are coming for the educational institutions and for the programs. And that's why we are having this symposium and trying to integrate the industry needs and the educational needs of industry needs as set up by the industry and by one of the leaders of the analytics community industry, which is IBM, which is, as I'm sure you know, the third largest player with close to 2 billion revenues in the analytics area and in business intelligence in general, and Boston University, which is the fourth largest university in the United States, private, and really which has been focusing on this for almost 4 or 5 years on this area. Metropolitan College and Computer Science Department at Metropolitan College started this initiative, I would say 3 or 4 years ago, and has been a slow but methodical process which has resulted in a new curriculum that we have come up with this within this year. And one of the panels later today will be focusing on the main steps of designing a curriculum in data analytics that will match the needs of the industry. So the structure of today's symposium we'll have 3 speakers. The first speaker will be coming from IBM, and it will be Dr. Ellen Hislal, which she's coming from the Watson Research branch of the IBM, and she will talk about the future directions in data analytics. This will be followed by Professor Irina Vodenska, which will be talking about big data analytics in finance and the opportunities and challenges in this area. And then followed by Professor George Zarvas from the School of Management, who will be talking about Groupon effects on Yelp ratings. He's professor of marketing, and it will be an interesting work focusing on computer science and analytics applications in marketing field. Then we'll have a break, followed by 2 panels. The first panel will focus on education, industrial needs, and career paths in this data analytics area. And the second one will be on the curriculum development and the best practices of developing a curriculum. The Computer Science Department and the Metropolitan College and Administrative Science Department are very well equipped, and they have experience in developing a large number of curricula. As you know, we have been leaders in the online education, and both our online programs are within top 10 rated online programs in the United States by US News and World Report. Our Masters in Computer Information Systems and Data Analytics is part of that, is the second rated online program in the United States, and the Master of Science in Management is number 8 out of more than 230 programs. So we really think that there are large possibilities, but we have to be in sync with the demands of the industry, and I'm looking forward really to get input from you and from the speakers at today's panel in the best ways how we can collectively make advances in education and also in industry needs in the area of data analytics. So at this time, I would like to introduce representatives of our college, of Boston University and of the IBM, to welcome you. First, I would like to ask Dean Tanya Zlateva, the Dean ad interim at Boston University Metropolitan College, to welcome the audience, and which will be followed by Bob Bree from IBM, from the academic initiative IBM, who will also welcome you on behalf of the IBM. So Tanya, would you please approach the podium?
I'm delighted you're here, and welcome to everybody on the internet who have joined us virtually. You won't believe this, but we have over 220 people joining us today. That in itself shows the interest and the importance of the field. The mission of Metropolitan College is to open the intellectual and educational resources of Boston University to the world community. And our focus is on professionally relevant, academically rigorous programs that draw upon all the colleges and draw upon the expertise of a stellar research faculty. Now, currently, there is hardly a more professionally relevant topic than data analytics. Now, understanding our environment and our society with quantitative and qualitative reasoning and methods has always been at the heart of both scientific inquiry and professional expertise. However, as Lou pointed out, the difference today is that we have unprecedented amount of data and readily available tools to analyze them and give us results that look, well, very imposing. There are graphs, there are charts, there are numbers about the data, predictions. And as readily available as there are, it is very easy to make mistakes. That is, we are readily able to make mistakes, to misinterpret the data, and predictably this is going to lead to really unfortunate outcomes. the way to avoid that, the way to benefit from this riches of information and computing power is to understand, to get educated, to really be able to reason with the new level of quantitative information and with the new level with evaluation approaches. So our symposium today asks questions such as, how can we develop educational programs that will give us the knowledge and skills to reason about data, to analyze situation, and to make good decisions? And how can we work with industry to understand the needs, to benefit from their experience, and to share what in the university community is developed in terms of new thinking and research. So I will hope that you will enjoy the discussions and the talks. I know I'm very excited about them. And now it is my pleasure to pass it to Bob Bree, who is the leader of the academic initiative of IBM in the Northeast, who has patiently and expertly worked with us for the last several years on shaping the collaboration, on informing the curriculum from the industry point of view, and frankly, we wouldn't be here today without Bob. Bob, please join.
Thank you, Dean Lativa, and thank you, Dean Kitchevas. I appreciate your comments, very kind comments, Tanya. I appreciate it. Well, good afternoon, everybody. As Tanya mentioned, my name is Bob Bree with IBM. I lead IBM's academic initiative here in the Northeast portion of the U.S., which means I work with many universities as we collectively together partner to help students develop and possess some pretty critical skills that are needed in the industry today. There is a skills gap that many of us have been observing over the past several years. And this topic of big data and analytics is one of those critical areas in which it's taking partnership between government, municipalities, industry, and academics to better prepare these students to face some of the world's greatest challenges. And so, as Tanya mentioned, I've had a chance to work with BU and BU Metropolitan College over the past several years, and I think we need to recognize BU's leadership in this space as it relates to advanced database management and business intelligence and other areas that are providing great opportunity not only for the students, but providing critical skills to the ecosystem. We share a lot of that ecosystem, our clients and our partners, ISVs, et cetera. So again, it's great to be here on campus. It's great to be with you, and I thank you for taking your time, faculty and students, and for those of you accessing this particular symposium remotely. I thought I'd provide some insight as to why IBM is involved in this sort of activity, partnering with universities, and give you some insight of how we are partnering and bringing together some of our clients and partners in the academic space. You may or may not know, but we're looked at in the industry as a key partner in bringing solutions to market in terms of software, services, and hardware, but we've gone through significant transformation over the past several years. In this time, we have actually seen some shifts going on in the industry, really going on across various industries in terms of data, cloud, and what we're calling systems of engagement. We understand that the challenges and opportunity associated with data have been around for quite some time. You have faculty here who have been focused on this space for decades. But if we really look at what's been going on, is that more and more organizations are looking to harness and develop the competitive advantage as it relates to data, better understanding data, developing new business models, to leverage that data, to secure that data, to extend that data and provide it in the right hands at the right person at the right time, whether it be in the shape of dashboards, scorecards, visualization, being able to have that data be leveraged across heterogeneous environments. And as we're talking about here today, this data really has several characteristics. Characteristics in terms of volume, 2.5 quintillion bytes, or 2.5 billion gigabytes created every day. It's a lot of data. So there's that volume of data. There's that variety of data, this unstructured data. Not only is the data relational database data that enterprise organizations have been collecting and storing and managing for decades, it is the social networking aspects of it, the tweets and the blogs, data outside the firewall, emergence of new platforms, emergence of new standards and ad hoc standards as it relates to open data sources and new database repositories. And I think what BU is doing is they're evolving their curriculum to represent that and to provide those skills. We also see velocity. This data is being created very rapidly, and organizations today are trying to harness and leverage that data as it's moving, no longer just data at rest. And so streaming technology, streaming data is fairly important as well. And of course, veracity. We see the opportunity here to help organizations not only achieve that goal of having a single version of the truth, but just have better confidence in the data and secure that data and governance and compliance. So these are areas commonly referred to sometimes as the 3 Vs or 4 Vs. And my colleague Ellen, Dr. Kislow, will talk more about that and how really big data is more than that and where the direction is going in terms of big data. But I wanted to highlight that we look at data as really the phenomenon of our age, that data is the world's new natural resource, that in every discussion about changes in technology or changes in businesses, it must begin with the data, because it's exponentially growing in terms of volume, variety, velocity. It promises to be what the 21st century was, in terms of steam power in the 18th century, or electricity in the 19th century, and hydrocarbons for the 20th. The data is fueling innovation, the application of invention to solve a problem, right? And so how they embrace that data, how they harness that data and do that with speed and do that with confidence and do that securely, these are things that are very important, how organizations are developing their competitive advantage in the marketplace and bringing new products to market, building new business models. And I mentioned cloud computing as one of those elements that's been emerging and growing quite rapidly in parallel. You can imagine today we have about 1 trillion connected devices. We talked about the 2.5 billion gigabytes created, and that 80% of the world's data is unstructured. So it's these business leaders who will drive better business outcomes through harnessing that data, better leveraging that data, enabling their marketing programs, enabling their customer support, enabling their financial services, all their business analysts. And the role of data scientist is becoming more and more critical in organizations today. And this highlights one of the areas that we see as a skills gap. Tom Davenport from the Harvard Business Review last year or a year and a half ago talked about the data scientist being the sexiest job title of the 21st century, right? What really is a data scientist? And some look at that as, you have those core programming, statistics, mathematical, computer skills, right? Combined with, strong concentration in computer science and perhaps even now industry experience, right? How can this growth of data be applied to solve some of these challenges that make sense for the organization, for the business, or for the ecosystem? And of course, there's that creativity, that scientific aspect of it. And so organizations are really looking at harnessing this data. You may not be familiar from an IBM perspective, but we've been very busy in this big data and analytics space. We've invested $24 billion specifically in big data and analytics. 17 billion just on acquisitions, sort of transforming IBM, and have amassed the industry's largest big data and analytics portfolio. We have 15,000 analytics consultants and mathematicians. We've completed 40,000 client engagements as it relates to big data and analytics. And 2/3 of our IBM research team, and I'm real thankful that Dr. Kislow's here because she's part of that organization. 2/3 of our IBM research organization is focused on data and analytics and cognitive computing. This new realm of harnessing this big data, harnessing cloud computing capabilities, this really new third wave of computing where we started with tabulation, programmable type computing environments, and that's where we are today, to the next wave of computing, which is cognitive systems. In January 2014, IBM launched a new group called Watson Group to bring cognitive capabilities to the market and to the world. Watson, some of you may recognize Watson in terms of a grand challenge, participating in the Jeopardy game show several years ago. We're taking those computing capabilities and we're really developing a set of solutions in market that allow for evidence-based decision-making, a cognitive system, a system that learns, that can understand a wide variety of data, corpuses of data, and learn and make evidence-based decisions, whether that be for oncology teams or managing risk in financial institutions. So you can start to see this new wave of computing that really builds upon this platform of big data and analytics, leveraging that data. So I just want to highlight here that we're very, very happy to be partnering with Boston University. We're partnering with over 1,000 universities to try to close this skills gap. I'll participate in the panel a little bit later, and we'll talk more about the skills. But we're seeing market data from organizations like McKinsey in 2011 that identified 190,000 job opportunities for people who possess these IT technical big data skills. But that report also mentioned that another 1.5 million jobs over the next several years will be available for let's say, maybe folks who aren't as technical, managing that environment. Marketing, sales, technical support. Data is pervasive. Skills-associated data are in great demand across various industries, and some of you represent those industries here today. Whether it be in healthcare, a great example, finance, and even disciplines within the organization in terms of marketing to get a 360 view of a client, things of that nature. So again, that gives you some backdrop a little bit on what we're seeing in the industry, why IBM is playing in this space, and why we're so interested in building such good partnerships with academics like we have here with Boston University Metropolitan College. At this point, I would love to introduce my colleague, Dr. Ellen Keslau. Ellen is a researcher within our IBM research organization. And Ellen, as you come up, maybe I'll read your bio here for everyone. Dr. Keslau received her PhD degree from MIT in 1993. She spent 15 years at IBM Research, working on nearly all aspects of automatic speech recognition and text-to-speech synthesis before shifting her focus to high-performance image analytics. She left IBM and co-founded MIM, Medical Image Mining Laboratories, in 2009, a startup focused on quantitative analysis of disease as seen in photographs taken with cameras, as well as lesions in 3D images such as CT scans. Ellen also did some consulting on other projects during this time, including cross-screen tracking of users and URL classification for a big data firm in New York City. In 2013, Ellen returned to IBM to work on low-resource speech recognition and works as part of our T.J. Watson research organization within IBM here in Cambridge. So, Dr. Keslau, thank you for coming.
So I entitled my talk, Big Data, What, Why, Where, and How. So the what is it all about, and the why is why do we want to do it. The where is more which industries can benefit from this type of analysis, and then a little bit about how does it all work. Eric Schmidt made an astounding comment a few years ago, and I'll just read it. Every 2 days now, we create as much information as we did from the dawn of civilization up to 2003. So that is just a mind-boggling fact, and it's important to keep in mind. But what kind of data is this? So it's coming from so many different types and sources. So we have all kinds of RFID tags, everything from pets to baggage on an airline, to FedEx packages are being tagged so that everybody knows at all times where their dog or their suitcase is. We have smartphones, not just with call logs, but also every time you open an app and connect with the app server, there's a data point there. We have queries going into Google, we have tweets, we have Facebook, and all kinds of financial data, just everything you can imagine. So one interesting aspect of all this is that about 80% of it is unstructured, which is in and of itself a challenge. So to make sense of it, you might want to consider, some kind of pre-processing to turn it into some kind of structured data as an option. And we'll talk more about that later. But I want to lighten things up momentarily, and I don't know how many people here are old enough to know who Lucille Ball is or have seen I Love Lucy, but there's a classic scene from the 1950s television show where she's working in a chocolate factory trying to keep up with the conveyor belt. So let's see if this works. Try one more time. Oh, thank you. It's maybe I'll just skip it. Anyway, it's kind of funny as she tries to go through these things. Anyway, sometimes big data can feel like that. But as Bob mentioned, it's more than just the volume of the data. There are 4 dimensions in which the data can be challenging. It's the sheer size of the data in conjunction with the velocity, the speed with which it's coming at you, and also the variety. So as I mentioned, all those different data sources earlier, some of it is like a one-dimensional signal, some of it is text, some of it is images, some of it is structured, some of it is unstructured, and just trying to bring all of those different sources together into one cohesive database is in and of itself a challenge. And then there's the veracity. So some sources may be better or more reliable than others, and we should be aware of that as we process. So in terms of the landscape, big data, I found a definition online of what big data is, and it's data sets that are too large and too complex to manipulate or interrogate with standard methods or tools. Okay, but it's really not a revolution as much as it is an evolution. So if you look at this chart, the scale of the data is on the y-axis and the decision frequencies on the x-axis. Big business intelligence and traditional data warehousing has been around for a long time and tends to occupy, sort of closer into the origin on the graph. And then as the size of the data, both at rest and in motion, or the data sets and the velocity are increasing, we get farther and farther away from the origin, and we start getting into this space, which is now called big data. And that encompasses both the storage aspects of things as well as the analytics. So a few words about why this is important. Looking first on the left-hand side of the chart, from a Gartner study, it's been noted that 1 in 3 business leaders frequently make decisions based on information they don't trust or that they don't have. So the intuition is still playing a big role in business decisions. And 1 in 2 business leaders say they don't have access to the information they need to do their jobs. And 83% of CIOs cited business intelligence and analytics as part of their visionary plans to make themselves more competitive. And 60% of CEOs need to do a better job of capturing and understanding information rapidly in order to make swift business decisions. So they need the data, they need it in a timely fashion, and the goal of big data is to help companies use their own proprietary data. So most companies now realize that the data that they can collect about their customers is their property, and it can help them get a competitive gain on their competition, but how can they harvest, how can they separate the wheat from the chaff to get insights and to make better decisions, increase their revenue, lower their costs, and things along those lines. So I think from a technical perspective, the problem can be viewed as having 2 major components, a database component and the analytics component. And from my experience working in the advertising space, I would say from a human capital, at least from my own perspective, about 70% of the effort was focused on the database side of things, and the remainder was focused on the analytics side of things. But your mileage may vary. I'm sure it could be different in different industries. Oops. Okay, so this chart is about the databases. So on the left side we have SQL databases, and the right side we have no SQL databases. So SQL databases were developed in the 1970s to deal with the first wave of data storage applications, and there's usually just kind of one type of relational databases in this category. And examples would be MySQL, Postgres, and Oracle. On the other hand, the NoSQL databases are, there are many different types. They were developed, 30 years later to deal with some issues in the SQL side of things, such as scalability. And some examples in this category are Mongo, Cassandra, HBase. So how does it work? Well, in the SQL world, we have records. So let's say we have a record like employee, and it's stored, think of a big spreadsheet. So employees would be rows, and there would be columns about the employees, like what's their salary, who's their manager, what date were they hired, et cetera. And then we might have another table, which is, offices, and let's say a large company has a bunch of different locations, and those are stored in the offices table. So if you want to find the address of an employee, you go to the employee table, you find out what office he or she is in, then you go to the office table and you look up the address. And you would do that using SQL with statements such as select fields from the table where blah, blah, blah. Okay, NoSQL databases are somewhat different. They're really, in the general sense, just a key value store. And you can grab the whole thing at once through an API. In terms of the schemas, the SQL databases tend to be fixed in advance. So if all of a sudden you want to add a field to your employees table, such as how many gold stars has this guy been awarded, you would pretty much have to take your database offline, migrate the DB to have this new column, and put it back online. Whereas the more modern databases can be updated without going offline. And I guess the most important row, at least from the big data perspective, is the last one, which is about scaling. So to scale an SQL database, you need to really just have a better server, more powerful, faster, et cetera. You can do some parsing and putting it on different servers, but then there's a lot of overhead, so it's not a huge win. Whereas with NoSQL databases, it's easier to replicate. Okay, a few words about analytics. With a speech recognition background, I'm aware of the old adage in the speech world, widely attributed to Bob Mercer of IBM in the mid-'80s, and Bob said there's no data like Mo data. And I think that holds true today for a lot of problems. Basically, the more data we have, the better and deeper models we can build, and the more insights, presumably, we can get from that data. But if we look at the chart on the right, we can think of how complicated or what types of questions we want to ask, and then how much of a competitive advantage we will get by solving that problem. So we can ask what, or what happened, why did it happen, and then we can kind of draw the vertical line and say, you know, what will happen or what is the best thing that will happen based on an analysis of the data. So if we're on the left-hand side of the chart, it's more of a report, a visualization, or a dashboard. And if we move to the right-hand side, then we move into the predictive analytics space. And predictive analytics encompasses a variety of statistical techniques from modeling or machine learning or data mining. A lot of them are the traditional models, like linear regression, Markov chains, maximum entropy, bags of words. A lot of stuff from natural language processing has found its way into predictive analytics, as well as collaborative filtering. And it's interesting to note that it can be updated, the model can be updated, you know, nightly or something like that as a batch process, but it needs to be fast to evaluate the model if you want to keep up with the stream of data that's coming in. So what can you do with big data, or where would it be important? Well, it turns out a lot of places. So financial services use it for fraud detection, risk management, and other things. Healthcare in terms of genomic analyses, disease surveillance, and other applications. Telecommunications, retail, and energy, law enforcement, digital media, lots of different places. But the ones that I'm going to focus on are the retail, and secondly, the healthcare. So we're going to look at one case study from the advertising space and a second one from the healthcare space. So before I get into the advertising, I want to take an aside and explain how retargeting works in advertising. So basically, the idea is you have a person surfing the web, let's say shopping for a camera. So they visit some website and they're browsing around, and then they leave the site and they go to their mail on Yahoo, they check the Knicks scores at ESPN, they go to CNN, and then while they're at CNN, they see a little ad for the camera that they had viewed on the other site. So if they're still interested in the camera, they click on that ad and they're returned to the original site. So that's what retargeting is, and it's one of the most powerful techniques currently used in advertising. So big data for advertising. Often the input is something like a weblog, where we have users, the events are URLs, so it's the track of websites that they visited, each of which has a timestamp associated with it. Often there's pre-processing that goes on using natural language processing methods. So for example, we might want to classify the entire World Wide Web in terms of a taxonomy. So it could be a hierarchical taxonomy where there are, say, 25 or 30 categories of things that I know about, like music, sports, philosophy, etc. And then if I drill down, sports could be polo or NASCAR or baseball or soccer. and you can continue in that manner. So the idea then is also keeping in mind that time order might be important. So if I'm making travel reservations, I might first search for a flight, and after I finish booking my flight, I might look for a hotel, and after I book my hotel, I might look for a car. So if things work that way, then it's important to keep time in mind, because if now I'm looking at a hotel URL, I don't want to show the person ads for a flight because they probably already booked their flight. However, I might want to show them ads for other hotels or for cars because that's what's coming next. So maybe the model would be a Markov model where the last n nodes in the taxonomy can form the state. And as we go through the model, we know where we're going next. So the output then would be the recommendation of what the person's likely to click on next, or an ad which is relevant to that next state. And then how do we measure how we're doing? We can look at revenue, we can look at click-through rates, we can see how close we can come to the retargeting rate, or other metrics. So as a second example, which is something that I did some work on, is cross-screen tracking. So there are third-party companies, for example, Drawbridge and Blue Kava, that claim to be able to track users across screens. So they gather some information about you on your laptop and then try to associate, so they know that, you know, based on your geography, the time of day that you visit certain sites, your zip code, other information, the browser version, lots of things that they can sniff while you're on the internet. Then they can try to build an associative model to say when this person is then later using an iPad or a phone or some other device, that I know it's actually the same person. And because that person visited Expedia on the web, I'm going to show that person a travel-related ad on their phone later. So that's the idea here. And looking at a case study of how Expedia used this technology, Drawbridge logs about 4 billion ad requests per day. And they have a model to associate various devices to the same household. So it looks at features like the time of day, internet usage behaviors, and so on to try to make those associations. And on a data set of 1 trillion observations, they claim to have matched 600 million unique desktops with mobile devices. So that's a fairly small percentage, but still it's a big number. And in an A/B test, Expedia noticed 336% higher conversion rates than without using this technology. So it actually is impacting their business. I want to shift gears now for a moment and talk about another industry and how that industry can use big data, and that's healthcare. Now, actually, in healthcare, there are probably more interpretations of what big data means than in advertising, where it's a little bit more clear-cut. You know, for some people, it means electronic health records. It means personalized medicine. I think one of the interesting trends lately has been these self-monitoring devices. So Fitbit, smart scales that can beam your weight up to a cloud, and apps like Map My Run, where you can enter sort of behavioral type activity, as well as recording your diet. If we could somehow use, for example, NLP again, to integrate all of this unstructured data that's coming from notes and lab results and narrative content with these monitoring type of devices, then, and put it in a central repository, and there already exists, for example, Microsoft Health Vault as an example of where this could all be kept, then we can monitor this data set for making predictions about one's health and possibly determining a personalized regimen for how to improve the quality of one's life or how to improve one's health. Also, a lot of the work in healthcare is either coming from these 1D type signals or from text. There hasn't been too much work on integrating images into all of this, but that's something that the startup company that I founded a few years ago looked at, which is we can also mine images and get additional information from those images. So for example, MS patients often go through a series of MRIs to look at the plaques on the brain and kind of track those over time. But since we have the brain MRIs as a time series, we can also mine those for signs of other disease as well. You can do the same thing with series of regular photos taken with ordinary digital cameras and analyze those for skin conditions like acne, rosacea, and psoriasis. And then you can, if you have access to the Health Vault data, you can couple those outcomes with diet, exercise, and other sources of information to maybe learn what triggers, for example, why someone had an acne breakout or things along those lines. In the healthcare space, though, there are some specific concerns. Privacy is a big one. Liability, at least from the provider perspective, is huge. Clinical trials are often required, and those are for this sort of software to make it into the workflow, and those are expensive and take a lot of time to bring together, as do FDA approvals. So those are some of the speed bumps, I guess, to bringing big data to healthcare, which other industries may not have to deal with. I just want to close with a few remarks, I guess, about to the students in particular about, what skills, if anyone were to be interested in becoming a data scientist, what skills are required. And it's really, there are a lot of different aspects of computer science that come into the picture. So from a programming perspective, Java, Ruby, Pig, Python, SQL, R, all of those are good to know. Databases, the NoSQL databases like Cassandra are good to know. And there's a platform by Apache, Hadoop, which has MapReduce, which is a convenient way to put a lot of jobs out on the cloud of servers and then bring the results back. So it's good to be able to do that. And ETL processes. There's also a big role for natural language processing and machine learning and statistical analysis. And then just sort of in parallel, but seems to be somewhat correlated, is the agile software development environment. So a lot of the buzzwords that I just mentioned are listed here, and it's just sort of good to be aware of them and know what they mean. So that's it. Thank you.
Very much.
Okay, so I will talk about data analytics in finance and mainly focus on the challenges and the opportunities, but I will also discuss some projects and ways we have used data analytics in finance and current ongoing projects. Some of the work has been published, some of the work is still in form of working papers, but nevertheless, the interest in finance for me is not only because I started in this field in the industry and then came to academia, but I felt at the time that if something happens in the financial world, so to speak, that this affects a lot of people. because it's not an isolated industry, it's not some remote place on the planet, but it's really something that touches everybody's lives. And we saw that, all of us, in the most recent financial crisis of 2008. I don't know of a person who has not been affected by that crisis or who has not been aware that it was going on. So we looked into lots of data after the fact, so to speak. And it was after the fact because even the people who are supposed to have access to all the data, to the reports of the banks, to the publicly available information, did not really have the tools to absorb all that data and to properly analyze it, or even more so, to create some sort of real-time monitoring tool, which is where the idea to focus in this field also mainly comes from. Because sometimes what happens in academia is we do have a project, we finish it, and it's on data between 2000 and 2005, and then the model is done, the data is done, the paper is published, and then we move on to another project. So how about taking that analysis or model and adding the new data and making it dynamic and see how the models should change to capture the dynamics in the development of the economy, the financial world. So I'm going to just briefly tell you some of the motivations that brought us here, but it is very known, we're all aware that the economic systems are related, and we live in a global village, and there are no borders, so to speak, to investments, to traveling, to internet, unless it doesn't work. So certain features of the system, though, are very vulnerable, and because of the interconnectivity of the system in economics and finance, if some shock happens to any part of the world or any part of the system, it's very easy to propagate to a different country, to a different market, to a different environment. So these shocks can be exogenous, like the 9/11. Nobody could expect that. And it happened. It affected greatly, negatively, adversely, the financial markets. Very short time after, the markets recovered. But when you look at the subprime effect, the endogenous shock in the financial markets of more recent years, it was very much prolonged, and we're still really suffering from its effect. So what happened in the subprime mortgage crisis is really not completely clear even to these days. But what is clear is that had the regulators, the policymakers, the central bankers, had the proper tools to analyze the data that was available on documents on mortgages given out, on different characteristics of the borrowers, on different backgrounds of the borrowers, neighborhoods, and had they had real-time dynamic tool to gather the information, to analyze it, to visualize it, and to monitor the state of the system, probably the crisis would not have been as grave as it was. And I'm saying this because there were people on Wall Street, actually, who did have these tools. There are few hedge funds, and there are few people who realized what's going on back in 2005. So just one piece of information. In 2005, approximately most of the subprime mortgage loans were in the form of fixed rate for 2 years that will adjust to a floating, much higher rate after 2 years. Well, it doesn't take too much to realize that starting in 2007, there is a high probability that the subprime borrowers would not be able to adjust to these new rates. So lots of people took this under consideration, took advantage of it, did the analytics, and started purchasing something called credit default swaps. But I'm not going to go into that right now. So Basically, the data is important to realize the state of the system, the dynamics of the system, and hopefully the predictability of the system. So we looked at all these aspects, and if you talk about the financial system, where the crisis starts or where the risks lie is in a formation, if I can put it in one word, of some sort of a bubble. So a certain asset starts increasing in value. It's very attractive. It's the American dream, purchasing a house. It's the tulips in Netherlands, beautiful. Everybody starts purchasing them. The price rises up to astronomical levels, and it's not sustainable. So looking into formation of bubbles is not that big of a deal. We could detect formation of bubbles. The main issue is we don't know when they're going to burst. And so everybody wants to ride the fast train, right, while it's going on. So besides all the other bubble formations that I have here, probably most of us remember the dot-com bubble from the 2000s. We all wanted to invest in high-tech companies. You didn't want to be left out. They didn't have cash on the balance sheet, on their financial statements, but who cared? The prices were going up. So little more thorough data analysis of financial statements would have probably stopped many investors from doing that. The United States housing bubble essentially ultimately created the European sovereign debt crisis as the governments started saving the banks. So data analytics in finance sort of comes natural. I don't think it's a new field. I think it's not well explored field. I think it needs to be much more developed and brought to a different level. But if you just look at this chart, I put it there so that without even knowing what's on it, I think everybody's eye will stop on that black line. Well, this is the market capitalization as a percentage of GDP of the exchange-listed companies for European Union candidates. And that black line is Iceland. So again, a mathematician, anybody with a quantitative background will start looking at the derivative or that slope of the line changing and becoming steeper and steeper, and probably would have become concerned. But sometimes I think people, even besides seeing formation of bubbles, they're sort of really prone to ignore them. So I think real-time dynamics, modeling and monitoring and signaling mechanisms are necessary to get out of that habit and really do something about it. Preventatively, it's like a vaccine, not waiting for the flu to break out and then everybody gets homesick. So there are also background reasons why this happened in Iceland, why the banking system collapsed. Well, in 2001, the banks became deregulated. Then the three banks held about 50 billion euro of foreign debt, and Iceland's GDP is 8.5 billion. Again, not a sustainable situation. In 2007, the economists ranked the Icelandic krona as the most overvalued currency, and this was a serious political and economic crisis in Iceland, and by the size of the country, it's the largest suffered by any country in the economic history, the largest crisis in political, social, and financial sense. So Iceland is such a remote island somewhere in the north. Why do we care so much about it? Because of this interconnectivity. So what I try to emphasize and try to bring up more in my talk here is that we do not live in an isolated village. Even if it's Iceland and it's far away and it's a very tiny country, we need to care for it because lots of depositors in the Icelandic banks were not Icelanders. They were foreigners, and these foreigners belong to their economies, and these greater economies are related to others, and there is no need to tell how international and how global financial institutions are these days. It's very difficult to grasp their complexity. And often when we were talking about lots of buzzwords like too big to fail, it really became the follow-up buzzword, too big to manage. And then the talk about breaking up financial institutions came to be popular. So the systemic risk, in a way, is what I think needs big data analytics, because it's not one type of data, it's not one way organized data, just like we heard before. Their data comes in so many different ways and different formats that it's very tasking work to first really bring it to the point when it can be well analyzed and understood and used ultimately. So looking into banking system, then the unemployment, and then all the social consequences, and then the housing market. So it came to be a global financial crisis transforming itself in the sovereign debt crisis that then Europe had to grapple with for a long time. So to give you an idea of some of the data sets that we have used for example, we used in our analysis the commercial bank balance sheet data of the United States banks, which really gives us all the assets, the liabilities, the equity, and all the ratios, the characteristics of the financial institutions in our financial system. So why did we do that? Well, because we noticed, even at first sight, that the banks that failed in the 2008 financial crisis were very different from the banks that survived. So that was a clue. And if we could now have this monitoring of the different characteristics of the banks and see which ones are stronger and more robust, the point is to make the others conform to this kind of stability and type or characteristics of their financial statements. We also used the US failed bank list from the Federal Deposit Insurance Corporation, and this is publicly available database. FDIC is publishing it on the web. Every day when a bank fails, you can see the bank name, the date where it fails, and whether it was acquired by somebody or it was extinguished. We looked into the largest institutional holders of something called gypsy sovereign debt, which includes the troubled European countries like Greece, Ireland, Portugal, Spain, and Italy, and modeled the distress propagation through the institutional network based on value reduction in these sovereign debts, which actually happened in reality. And then we looked into different pricing data from Bloomberg, such as foreign exchange rates, global financial market indices, or great default swaps. And last but not least, we also have Thomson Reuters news sentiment data, which was also mentioned in the previous talk, the importance of machine learning, text mining, and finding the relationship or the influence of news on financial markets or financial markets driving news contemporaneously or causally. And so this was interesting to look at. So just to give you an idea of the size of the data, we analyzed in the first data set approximately 7,000 banks and picked 13 relevant assets for 30 years. So that's about 2.7 million data points. So the other set, the FDIC list, was just 500. There were 500 banks on the list. It's small. Is it important? It is. So the data set of the institutional holdings also had about 500 data points. The Bloomberg data, the financial market pricing data, had about 200,000 data points to analyze. And then the Thomson Reuters daily indicators, sentiment indicators for countries, amounted to something close to 17 million data points. And we also have the intraday 24-hour minutely rolling sentiment data, which amounted to something like 25 billion data points. And we realized we are not even close to the sovereign debt outstanding of the United States of America. Anybody knows how much is it? It's a bonus question for the end. So a big financial risks have started mushrooming in the system from many different areas, and this is why we needed different type of data and different sizes of the data sets to look at them. So basically, in the banking financial statement analysis data, this is the first thing that really struck me. I don't know if it strikes you, but between 2000 and 2007, 27 banks failed in the United States of America. And between 2008 and 13, there were 470 banks that failed. So this was already a pretty good data set to test our model against, to see which assets were the culprits, the concentration in which area were the culprits of this mortgage or banking financial crisis. And this is the failure of the banks per state, with Georgia, Florida, and Illinois leading. And you cannot see Massachusetts because it's somewhere towards the end, which is where we are. So in the financial institution network, we created bipartite network, and we analyzed the interrelationships between the assets on the balance sheets of the banks and the banks themselves, their health. So what happened is, as we looked into certain asset and we reduced the value in the model, the risk was propagating and making certain banks to fail, and certain banks survived this systemic risk propagation. So the banks that survived had different characteristics from the banks that failed in sense of the concentration of certain assets on their balance sheets. So if you look at the loans for construction and land development, the red is the failed banks, you see that there are many more with higher concentration in these assets compared to the all banks. So I'm going to stick with that asset for a while and talk only about that because I wanted to tell you something more about some other exciting uses of the data, the other type of data. But if you also look at the leverage ratios, the failed banks were much more leveraged than the banks that survived. In other words, these banks had so much liability on their balance sheets, they had to pay somebody else to that extent that any reduction in their asset or capability to pay their debts was going to wipe them out. So we did certain simulations, and we figured out that for that particular one asset, loans for construction and land development, when we damaged the value of that asset, there was a clear separation between the failed bank's survivorship rate, which is the red lines, and the blue lines. So naturally, we wanted to further look into that asset. And then we had the model identify which banks are going to fail if that asset is greatly damaged, which is a loan for construction and land development, and the predictability of what our model identified compared to the real list of the Federal Deposit Insurance Corporation was matching in a very significant way. So the area under the curve here was pretty large for that particular asset. And then looking into other assets that we analyzed, you notice that for agricultural loans, for example, there is no predictability whatsoever. The agricultural loans were not defaulting and were not, in general, dangerous for bank failures. So that was an interesting finding, and it turned out that this was also interesting. So other countries, colleagues from other countries, from Latin America, from Europe, from Japan, started doing similar analysis, and we were finding similar results of the types of assets in different countries. So when we looked at the investor institution data, we realized that if you look at this chart, for example, the sovereign debt of many countries after about 2008 has an upward trend. Now, on purpose, I just stopped at 2010. Okay, so we know what's going on in 11, 12, 13. And it's just interesting to see that not only the troubled countries, but the countries that are not troubled or considered solid have a very upward trend in amassing sovereign debt on the government balance sheets. So this is something that's unsustainable too. So next step for us will be just not analyzing the troubled European gypsy countries, but analyzing the entire sovereign debt holdings on big institutions around the world and see what the model will tell us, which one is the most dangerous. So the sovereign debt crisis in Greece and Ireland is pretty tiny again. Like I mentioned with Iceland, these are not big countries. Collectively, the Greek and the Irish GDP, smaller than the GDP of Pennsylvania. So why do we worry so much about it again? We need a different look into the data, and we need a network type of look, topology type of look, connectivity type of look into the data, and analyze it in a very different way from the originally or traditional economic point of view. So there were many changes based on this financial crisis and the European sovereign debt crisis in sense of regulations, certain increased reserve requirements for the banks, the central banks saving some of the institutions. But ultimately, this is again a static measure. We know the data, the banking authority, European Banking Authority will do the stress tests and then it's done. And then wait a certain period of time and then do the stress tests again. So the point that I'm trying to make is we have the data and we have the macroeconomic data, we have the data analytics tools, we have the technology, so we need to use it to create more real-time and dynamic type of tools based on data analytics. So the sovereign debt of these countries had different characteristics. Italy and Spain are large. Italy is the largest by all means. And given that most Italian banks hold Italian sovereign debt, you see, for example, one bank, Intesa San Paolo, held 80 billion euro of sovereign debt. Just one bank. And this is after the European Banking Authority had demanded that they reduce the exposure to sovereign debt. So the Italian and Spanish debt dominate, followed by others. So there are different types of charts that we can create and see what's going on. But the idea is to go beyond that, to use the technology power and the data analytics to really create a better monitoring tools. So we look at the distributions, we looked at the holdings in these different debts. We created a model for stress propagation. And again, we found some pretty interesting results. There were certain communities that were being formed of banks that are stable and banks that are vulnerable. So if we could see it, probably the regulators could use that and see it as well and say, well, look, maybe we should keep a closer eye on these vulnerable banks because they may become a problem. Mm-hmm. So the connectivities of financial systems are also not only in the banking system, but across financial markets. So we looked in the distress propagation model for different types of networks, mainly foreign exchange, stock markets, etc. And again, you look at certain correlations, you look at dependencies, and you see some clustering of interdependencies, and the markets start behaving in a more similar fashion. It's an alert sign. This is a result of a distress propagation model, and how long does it take for one market to affect all the others for different markets, for foreign exchange and for stock market, and the credit default swaps market. Now, what's interesting also is if you look at the stock market, even though we see the mean of the correlations increasing, there is also increase in the standard deviation. But if you look at the credit default swaps, while the mean was increasing in the crisis years, the standard deviation was flat. So it all went in the same direction, which shows higher risk in the system. And let me just give you a brief overview of what we did with the financial data. But this is a minimum spanning tree of financial markets, which are the red nodes, and news for these same markets, which are the blue nodes. And immediately you can see that the red nodes are like the highway, and the blue ones are the roads, the side roads. So this really means that the financial markets are the backbone of the financial news and market network, and they are affecting it. And there are many more important financial markets than financial news sources, so to speak, if you want to look at the effect on other, or the spillover effect to other markets. These are some lagged correlations, and again, in the news universe, there are not that many. It's a day lag, and then when you come to markets to news, the lag correlations become more dense, and then markets to markets, they really affect each other. So we did detect also certain communities of markets that could be predicted by a community of other markets, which is also pretty useful in today's financial world. So let me just quickly close with the challenges and the opportunities. But basically, we still have the same challenges as before with the smaller data, or not so much emphasis on analytics. We still, besides finding statistical significance in our results, need to find economic significance. And without this thorough analysis, we're running a risk of having a signal-to-noise ratio coming to zero. So what's needed is better answers, not merely more data, and predictions to be made in dynamic, not a static world. Now, the opportunities, I start with big data has arrived, but big insights have not. And I do see this as opportunity because we have a lot to do, lots of work to do to come to those big insights. Moving from static to dynamic data analysis, performing data analysis in real time, and really ultimately helping regulators to get used to this real-time monitoring instead of annual or triennial stress test results. The new approaches, such as network science, complex system theory, and last but not least, visualization. Very convincing visualization to understand and to really see what's in the data. So I just wanted to bring this up because John Leichty from Penn State University said financial markets are at least as complicated and important as the weather, but we don't have the equivalent of National Weather Service or National Hurricane Center for financial markets. And he's right. And then Hal Varian of Google said, to make money, you've got to predict two things: what's going to happen and what people think is going to happen. So opinions matter more. And finally, big data can help in improving modern society, can be helpful for bringing together different disciplines and also different areas like academics, financial industry, and regulators together to tackle the problem. The challenges for the governments and regulators, as I mentioned before, was that they did not have the right tools in 2008, but the big data can assist policymakers by offering the possibilities for creating these dynamic monitoring systems. And thank you very much. If you have any questions, I'll be happy to answer.
Ina?
I'm very glad to be here, and what I wanted to talk to you about, despite the very specific title of my talk, is an application of data, not necessarily big data, gaining insights on a new marketing method that took the marketing world and the business world by storm approximately 4 years ago. What I'm referring to is daily deals, and more specifically Groupon, the company that sort of invented this business model. Most of by now will have probably heard of Groupon, but for those that haven't, Groupon is a multi-billion-dollar electronic commerce marketplace that connects businesses, usually small businesses, to consumers by offering discounts and promotions. The way it works, and I apologize for the resolution, if you go to the Groupon website, you might see something like that. So this is a coupon for sailing that you can buy for $65. And the big feature here is that the price of the coupon is usually, of the product is usually $135. So you're getting a substantial discount. And Groupon offers those discounts every day in great variety throughout the United States and worldwide. Their business model is quite simple. There are three parties in this exchange. First of all, the consumers. This would be you and I who buy the coupons. Then there are the businesses, your local restaurants, spas, gyms, and whatnot. And then there is Groupon. So whenever you buy a coupon, like the $65 coupon that I display here, Groupon maintains 50% of the value of the coupon. So $32 will go roughly to the business, and $32 will roughly go to Groupon, all right? So the business is essentially offering you a 75% discount. Very good. So using this very simple business model, Groupon managed to grow tremendously in a very short amount of time. And I'm not sure how many of you remember, at the time it was called the fastest growing startup ever. Its revenue grew from practically zero in 2008 to approximately $3 billion in 2012. And the number of subscribers, the number of consumers who were signing up to receive those offers from Groupon grew from zero, pretty much, in 2008 to approximately 200 million subscribers in 2012. And I'm sure these numbers are even bigger now. These numbers are slightly updated. Owing to the success of Groupon, many other businesses try to replicate this business model. I have a few here, Living Social, Guild, Amazon, you name it. Unfortunately, not everyone was as successful. Some companies just folded. In fact, out of the approximately 10,000 daily deal publishers that I counted with my co-authors, around 2011, 10% of them just folded in the last 6 months of 2011. Groupon itself is a public company, so we can see how it's doing on the stock market. And its stock price has been an absolute roller coaster. So you cannot really see the y-axis here, but its IPO price was approximately $20. Within a day, it jumped to approximately 30. A year later, it was near $3. And if you check the price today, it's, what is it? Approximately $7. So it's all over the place. Motivated by these observations, my co-authors and I started wondering, can we learn more about this business model? And in particular, we had two questions in mind. The first one is, as an entrepreneur or as an investor, should we invest in businesses like that? Should we start a business like that ourselves? They seem to be hugely successful. The second question was, as a small local business that wants to attract consumers, should we be offering a Groupon? Should we be offering our products and services for 75% off? How might that affect the reputation of our business? All right? So these are the two questions that we wanted to ask. And usually, to answer those questions, we might go and run a survey or might collect Groupon data. But in this case, I want to argue that we can learn more by bringing together disparate data sources and matching them together. Specifically, for our analysis, we looked at Yelp reviews. I presume that most of you are familiar with Yelp, but for those of you that aren't, it's simply a website where consumers go and review local businesses. This is what Yelp looks like on my left. So you can see here the listing for Cha Cha Cha, which is a salon in the south end of Boston. These are some reviews. Here is a 5-star review by a happy consumer. some opening hours, the price range, and other useful information. Cha-Cha-Cha is also very proud of its Yelp rating. So when I was walking outside the salon, I saw the sign, I took a picture of it, and you can see that the only thing they display is pretty much the fact that they're open, the name of the business, and that they have 4.5 stars on Yelp, which is actually not quite true. They only have 4 stars. So businesses really care about the Yelp rating. Interestingly, if you scroll down and try to read more of the reviews, you will notice that consumers do mention when they visited the business using a coupon. And this is what we're trying to exploit to understand more about this business model. So you might ask, why Yelp ratings? It seems rather far-fetched. Well, here's my answer. First of all, Yelp is absolutely enormous. It has approximately 30 million reviews, and that's slightly outdated again. Pretty much every local business I know of is on Yelp, and businesses cannot opt out. There are at least 2 papers that I know of that have causally associated increased Yelp ratings with increased revenues. So a 1-star increase in your Yelp rating might lead to up to 9% increased revenues. And for restaurants specifically, half-star increase was found to increase the probability of a restaurant being sold out by approximately 50%. So that's why businesses care a lot about Yelp. They also care a lot about Yelp, and they spam it a lot. So on Yelp, you will find quite a few fake reviews. And finally, Yelp reviews are forever. So unlike offline word of mouth, online word of mouth persists. So if you get a bad review, it doesn't simply go away. It stays there for future consumers to see and act upon. So here is what we did. We collected a data set, and as I warned you, it's not very big. So first, we looked at Groupon for approximately 6 months, and we collected every single deal that Groupon offered in 20 large North American cities. This is approximately 16,500 deals. Then we looked at Yelp. We linked those businesses with their associated Yelp listings and collected all of their reviews. Our data set in the end contained approximately 7 million reviews for 1 million businesses, and I will explain why we have more businesses in the latter data set than we do in the former. All right, so before I give you our answer, which is based on what the data says, I want to tell you what Groupon thinks the answer should be as to whether you should be running a Groupon deal. So Groupon has a website for businesses, for small local businesses, to go and sign up, and they make 2 claims there that I have copied for you here on the screen. The first one is that you get advertising that works and makes you money. The second one is that you get great customers, good customers, happy customers that might get a discount today, but they're going to come back in the future and pay full price and come back again and again and again and eventually be profitable. So if Groupon's claims are true, then we expect to see 2 things in the data. First of all, increased word of mouth. So maybe after you run a Groupon deal, you should get more consumers and more reviews. And if these customers are truly happy, then the ratings they give to your business, they should be no different than the ratings you were getting anyways. Maybe they're going to be even better. But certainly we hope they're not lower. So here is what we did. This is a cartoon version of our data set. So you can imagine that we have 3 businesses, and these are their timelines. And they maybe get some reviews before they offer a Groupon. So 5 stars, 3 stars, 5 stars, then they offer a Groupon, and they start getting maybe more reviews. So as a first step, we'll take our data, and we're going to align everything so that we know which reviews came before their respective Groupon offers and which reviews came after the respective Groupon offers. And if we do that, and we plot all 16,000 businesses together, we see something like that. Now, I know this is a very busy chart, so let me walk you through it. So along the x-axis here, I simply have the number of days from the Groupon offer that the businesses offer. So minus 90 means approximately 3 months before your Groupon offer, plus 90 means approximately 3 months after your Groupon offer. The gray bar, which is hardly visible here, I apologize. Can anyone see that? I'm afraid not. All right. So the gray bar along the bottom is the number of reviews per day that these businesses were getting on that specific offset. And what you can see here is a sharp discontinuity. The number of reviews that businesses get immediately jumps the moment they offer a Groupon offer. What happens? Many people buy the coupons, they go, they try the businesses, and then they review them on Yelp. The other thing that you notice, I have highlighted this subset of reviews here. These reviews actually mention the keyword Groupon. These are consumers that used Groupon to visit those businesses. So far, so good. Now, on the second chart, on the top, I have plotted the average rating of those businesses on Yelp before and after they ran a Groupon. So you can see that for approximately a year before, it's hovering around 3.75 stars. And then the moment they ran Groupon, their Yelp rating declines substantially. There is a very sharp discontinuity. In fact, the difference between the pre and the post rating is approximately 0.2 stars. And for those of you that use Yelp, you will know that this is a huge difference that can make or break a business. Another thing that we found is that this difference was driven by users using Groupon. So when looking at the darker gray reviews, which contain the keyword Groupon, versus the reviews from other customers, we found approximately half-star difference. So people who were mentioning Groupon in the reviews were far more critical than their peers. Another interesting feature of this chart is another discontinuity at 180. So this is approximately half a year later. What is going on half a year later? Well, most of these coupons also carry an expiration date. And for most of them, the expiration is 6 months. So a bunch of people remember that they bought a Groupon back here. It's about to expire. They cannot use it anymore. So they go to the business, maybe a bit late, and they use it. They go back to Yelp, and then they complain about their experience. Another feature of this chart that surprised us is that even after the expiration date, most coupons have expired here, maybe just a few here. On average, ratings do not recover. So by that point, which is more than a year later, you're hardly getting any Groupon customers. And yet, the ratings that you're getting are far lower than what you used to get back before you ran a Groupon. So this has caused substantial damage to your reputation. And the question is, why? So we came up with 5 reasons, and I will briefly present them. The first one is, maybe it has nothing to do with Groupon. Something that we have observed in marketing is that ratings and scores tend to decline naturally over time. Why is that? Well, you can imagine that maybe if you're a Harry Potter fan and you've read the first book, and then the second book comes out, you will be among the first people to buy the book. You will give it 5-star on Amazon because you're a fan of Harry Potter. And then maybe your friend who is not a fan of Harry Potter later will buy the same book, but will not like it as much and will give it 4 stars. So in a sense, people who really like a product, a service, or a business tend to review it earlier. So maybe this is all that's driving this effect. Why should we blame Groupon? The other hypothesis we want to test is that it's maybe the reviewers. It's you and I. We're just cheap and cranky, and even if we get a discount, we're simply going to complain. The third hypothesis, which I prefer, is blame it on the businesses. It's not me, it's them. Maybe when I go there, they're unprepared. There are many other Groupon users. They cannot handle the volume. Maybe they give me a smaller portion of food because I'm paying them less money, and they actively discriminate against me. The fourth hypothesis, let's not blame anyone, neither the consumer nor the business. It's simply a bad match. Maybe I'm not into sailing, the coupon I presented before, but you know, for 50% off, I will try it. I wouldn't have paid full value. What does that mean? Most likely I will be disappointed. And finally, this is a specific feature of online reviews and Yelp. Many reviews tend to be fake. So one thing you can imagine is that prior to Groupon, some fraction of those reviews that brought you to 3.75 stars were not actually real. So maybe what's going on here is the following. Groupon users just go and buy your coupon, they visit your business, they write their honest reviews, these reviews are accurate, and they simply deflate your rating because your fake reviews are now a smaller proportion of your overall review volume. All right, so let me skip that. So let's look at this hypothesis quickly one by one. I told you that ratings decline over time. Well, here is the proof. Let me quickly explain this chart. All we have done here is this is your first review, your second review, your 40th review, and your 100th review. And all this chart says is that, indeed, earlier ratings are a substantial bit higher than later ratings. So when we're doing our analysis, we certainly have to factor this in. Our second hypothesis was that maybe it's the businesses. And unfortunately, here I cannot offer too many insights because our data set did not have that kind of richness, and this is something we're looking into extending. But here are a few things that we found. First of all, the most surprising thing was 1 year after offering Groupon, 10% of the businesses that offered it had closed. It absolutely disappeared from the map. That doesn't inspire you with a lot of confidence that these were good, successful businesses to start with. Another thing that we found, and at least we found a lot of anecdotal evidence, was that if you look at the reviews, and I think that speaks to the difficulties in working with unstructured data, and this is something we're trying to get better at, you can tell that many Groupon users felt unsatisfied because they were treated, as this reviewer puts it, as second-class citizens. And while it is prevalent in our data, it was a bit harder for us to actually code. Finally, the other thing that we found is that not all businesses are bad. Some of them were smarter in setting up the terms and conditions of their deals. So approximately 30% of them ran capped Groupon deals. That means they only sold a limited amount of coupons, so it was easier for them to satisfy the volume. And also, approximately a quarter of them required you to make a reservation in order to use your coupon, so that you wouldn't go there and wait in a long line and be disappointed. So there is a lot of variance there. All right. I also asked before whether we should be blaming the consumer. So here is what we did here. There are all these people like you and I who went, bought a Groupon, visited the business, reviewed that business, and gave it a low score. So here I'm going to look at how I rated other businesses when I was not using a Groupon. Because if I'm truly cranky and cheap, maybe I will be giving low scores to businesses whether they offer me a discount or not. Long story short, what we found is that Groupon users, as a population, are not more critical than their peers. Their average rating for non-Groupon businesses is approximately the same, 3.71 stars versus 3.76 stars. And the distribution of the ratings, if you look at that, I would say they're slightly more moderate in their reviews. They give fewer 1-star ratings, fewer 5-star ratings than their peers, and a few more 4-star ratings. But nothing too scary. This is not a consumer that you would like to avoid. Our data contains some further insights about these users. And briefly, they just tend to be more popular on Yelp and on social media. As Gladwell might put it, these users are mavens. They're more likely to discover your business, more likely to review it online, and more likely to tell their large Yelp network about their experience. So in a way, these are people that you might like to attract, not people that you might like to avoid. All right, hypothesis 4, experimentation. Here is what I mean by experimentation. Let me quantify that. I'm talking about things that I have not tried before. And how do I measure that in the data? Well, that proved to be tricky. So we used 2 proxies. We know for every user, so you can look at my Yelp history, what type of businesses I like to review and where they're located. So maybe you know that I like Italian restaurants, and usually the restaurants I visit are in 0 to 139. Then as you're browsing through my history, you notice that I visited a restaurant in 0 to 215, and maybe it was a French restaurant. And I have never visited a restaurant in that zip code before, or of that cuisine before. So this is what we're going to call an experimental review. Something that stands out in your Yelp history. All right? So when we do that, here is what we find. We find that when using a Groupon, consumers are 4 times more likely to experiment, 35% versus 9%, than when they don't use a Groupon. So these discounts make consumers try out new things. And if you're a business, I think this is a valuable insight. You might expect less familiarity with your product or service on the behalf of Groupon consumers, and you might want to prepare for that. And for our final analysis, we looked at fake reviews. And we asked whether your rating was artificially inflated before. So maybe your rating after Groupon more accurately reflects the quality of your business rather than your rating pre-Groupon. And we found some evidence of that. So Groupon users are less likely to write reviews that are perceived as being fake, and the ratings are slightly lower. So maybe there is something going on here. All right. So, to conclude, I wanted to argue with my presentation that we can gain powerful insights into marketing problems at least, not only by accumulating large volumes of data, but by linking and matching disparate, seemingly disparate sources of data together. From a managerial perspective, I would say Groupon is not particularly bad in the sense that it attracts bad users. These are users that are very well connected online and can bring with them more business. Groupon is not well suited to businesses that have limited capacity because they cannot deal with that. And finally, I think one of the insights of our study was that if you're a business considering running a Groupon deal, one of the things that you should take into account in a decision theoretic framework is your current Yelp rating, as well as that of your competitors. And finally, as far as Groupon goes, in terms of its business model, one thing that it has to do is break the link with bad Yelp ratings. So instead of focusing on driving more and more consumers to businesses, it should focus, I think, on driving quality consumers that are well matched to the coupons and the promotions it advertises. So thank you. That's my talk.
The panel is titled Education, Industrial Needs, and Career Paths in Data Analytics. We have 5 members of the panel, and I wanted also George. Is George Zervas here? George, would you please join the panel before I caught you before you left? So it's good, because I really would like audience to have opportunity to ask George questions. So members of the panel, Alan was our speaker, Bob was introduced already, Andrew Banasiewicz, professor at Boston University I wanted to say of analytics, but it's administrative science and analytics. It's in our administrative science department at Metropolitan College. Then Professor Suresh Kalatur, who is with computer science department, and he's the leader of the analytics curriculum development at computer science department. And we have another leader from the administrative science department, Dr. Vladis Latev, who is professor at the administrative sciences department, and he has been one of the main champions of analytics in the administrative science department. And George, we have already heard from George. I'd like to thank him for the presentation. So I'd like to start with I'd like to ask each member of the panel for introduction, a brief statement about the special area of involvement in data analytics, and then we'll start with other questions from myself or from the audience. So, Bob, please.
Thank you, Lou. Hi again, everybody. This is Bob Bree from the IBM Academic Initiative. My involvement with analytics, specifically within IBM, is that I, as I mentioned earlier, lead what's called the Academic Initiative in this region. I partner with universities. I assist faculty with the adoption of big data and analytics technologies in their curriculum and their courses. I first started getting exposed to analytics as I was working in software group, as what's called, I was an acquisition enablement manager in IBM. And about 8 years ago, we started acquiring a lot of different technologies in IBM, as I mentioned earlier, $17 billion worth of acquisitions. Companies like Cognos. I first started getting exposed to Cognos about 7 years ago. IBM invested $5 billion in acquiring that one company alone, as an example. SPSS, other set of technologies some of you may be familiar with in terms of statistics, but we also have data modeling and decision management. So my exposure to analytics and big data has really been from working with IBM, teaming with our technical sales and IT architects over the past several years, and now in the form of working with faculty and assisting faculty as a curriculum consultant and bringing in volunteers and ambassadors to partner with our university faculty partners. So again, good to be here on the panel. Looking forward to chatting with you.
Thank you, Bob.
Hi, I'm Ellen Eid-Kislow. I have worked for a number of years in various machine learning type projects, and I did consult for a big data company in 2013. I would say my expertise is more on the analytics side than on the database side, and it's interesting that even though my education and early experience was in the speech recognition area, it was very relevant. So I was able to bring a lot of NLP knowledge and maximum entropy modeling techniques to the space of big data analytics. So that was nice and rewarding, and here we are. So that's it.
Andrew?
Hello, Andrew Banashevich. I'm relatively new to Boston University, and prior to joining the faculty, which I did a couple of years ago on part-time basis and just about a year ago on full-time basis, I spent, about 17 or so years working in the industry. And so I worked in an area which right now is known as predictive analytics. So I started out in the marketing area, working for a large research company called Nielsen Research, and then about halfway through, I switched and went to work in risk management. And so throughout the entire 17 or so years, I spent just about all of my time developing predictive statistical models for various decision-making purposes. So a lot of the opinions that hopefully I get to share with you today are frankly informed by quite a bit of experience that I've had in the industry. So glad to be here as well, and glad to share the panel with my colleagues here.
Thank you. Suresh?
Yeah, I'm Suresh Kalatu from Computer Science Department. So my interest in the analytics or data mining started way back. So in 2005, we started our first data mining class. So at that time, so teaching the class is one thing, and also giving interesting topics to the students is another issue. And I was interested in seeing what are the things that are relating to data which appear in everyday news. And I started collecting them, and I realized that we need to have a better way of doing it. So I started writing a program. And at the same time, my son was in middle school, and they had these competitions about the news events. I said, okay, I have this program. I can input the data into the program. And then he's fine. He went to the college, and he's done with that. And now my daughter is in the middle school, and I said, okay, I'm not going to enter all the data, all the news items all over again. So again, I wrote the program, which will automatically collect the news items and keep it in the database. And she will come to me and say, Dad, tomorrow I have the test. I need the last 2 weeks news items. Here we go. There comes the printout. Okay. And if you have a middle schooler and they do the current news, so just let me know, and I'll be happy to share the information. They're guaranteed to come in the top 5 of the class. And there are various other things. Yeah, anything that is related to data. To most of you, you in everyday life, all right? So unless you are a millionaire, you are interested in what is happening to your money that is coming in and going out. You drive your car every day. You're interested every time you fill up the gas and you see the bill $50 for filling up the tank. You're interested in how much mileage it is giving. So unknowingly, you're actually looking at the data in everyday life. And obviously, through our courses, we are going to explore that type of data and see what we can do with those data. All right, thank you.
Hi, my name is Vlade Zlatev. I joined Boston University 4 years ago. I'm an industry practitioner. My background is industrial engineering and management. I will define our mission to teach students how to apply analytics using the 3 pillars of the analytics cycle. The first one is industry knowledge. Second is how to analyze data. And the third is you as an expert who is changing the picture by applying all these analytical tools, but also learning more about your profession. So in our programs, we are applying a lot of models and instruments thanks to IBM. 3 years ago, I introduced to my students SPSS statistics and how to apply it in a course called Market Research and Analysis. And sounds complicated, but it's extremely powerful. And we are still using these instruments on a daily basis in other courses, including quantitative and qualitative decision making.
Thank you, Vladi. George, tell me, how is it to be a computer scientist in a marketing department, traditional marketing department?
I think my colleagues suffer more than I do. So having actually, it's really interesting. So I've traditionally worked with data, but sort of been completely blind to decades of management and business research. My background is in computer science, my undergrad, my master's, my PhD. I ended up in the marketing department, and I'm very fortunate because now I get to test the predictions of decades of marketing research using data, which I love to collect and analyze.
Thank you. I'll start with the first question, which is what are the main career paths and possibilities that you see in data analytics? So anybody from the panel can answer that question.
Thanks, Lou. It's interesting. From a industry perspective, IBM Corporation, we have a lot of clients. We have a lot of our Fortune 500 clients who invest in data and analytics in various different ways. I think what we see, and as I partner with universities, there's this rise of data scientists. That's obviously a title, it's a discipline, but we also see data. Data is this one thing that is providing opportunity for people outside of what might have been traditionally been computer science domains and disciplines, as George's presentation and marketing covered, right? Developing new models, understanding customer buying patterns, looking for upsell, cross-sell opportunity. We're seeing analytics. We work with an organization in Europe that creates large wind turbines, right? Understanding weather patterns, understanding how to get maximum efficiencies of these things. We work with Toronto, a hospital in Toronto. So medical fields, right? Understanding data analytics and doing predictive analytics with health teams to provide better opportunity, for example, in this case, identifying sepsis a full 24 hours compared to traditional means in a neonatal care unit. So we used to talk about computer science domains, but data, understanding data, analyzing data, interpreting data, doing predictive analytics on that data is now a skill that we're finding in many different disciplines. And it's hard to determine those just by title alone. And so there are other reports that have come out recently. Even McKinsey, we talked about the 2011 report, but even McKinsey in March 2014 came out with a report saying 50% of CIOs are saying that they're having a very difficult time recruiting talent, IT talent, as relates to big data analytics. Not just recruiting, but maintaining and developing that talent internally. So it's a current thing as well, and it's happening in many different disciplines and many different domains.
If I can add to this, based on my experience, what I've observed, what has been happening over the past several years, because as was illustrated earlier, the amount, the volume, the veracity, the variety of data has exploded so rapidly. The term data scientist is becoming, and I do agree with my colleagues that it has been the occupation du jour, if you will, of the past few years, and I have a number of former colleagues and friends who do bear that title in various industries. But it's becoming more and more industry specific, because when you think about it, the types of data that different industries have. So for instance, when I worked in marketing, and the data that marketers typically have, and a lot of it comes from electronic transaction processing systems and like mechanisms that virtually all companies basically share in common. And then when I switched over to risk management, completely different data coming from completely different sources. And so in order to be data scientist, sometimes we glaze over the term data and start to think automatically in terms of statistical methodology. But what happens, the differences in terms of the data itself are so significant across these different sources and types of data, and the techniques that are used, and both for data manipulation and transformation as well as for data modeling, are so typically different. So in insurance, the assumptions, the techniques, and the type of data are very different than those used in marketing. And so what is the reason a lot of organizations have difficulty filling these positions is because if someone knows statistics, but they don't know the idiosyncrasies of particular type of data, then it's a fairly long learning curve for that person. And so the companies want to find someone who has that particular experience with that type of data. And so, so I think for us as educators, that means that we have to bring more of it to the classroom, because, I mean, where do people learn it? So it's a chicken and egg, right? I mean, if you have to have experience in order to get job, and you can't get job without getting experience, then something has to give here. So so I think the importance of understanding the specifics of a particular type of data have been accentuated by the rise of big data and the fact that in every aspect of industry there is so much of it, so much so that that one needs to really spend quite a bit of time to understand it. And I do know it from experience, it has been painful getting into a new area, because you make an awful lot of mistakes and spend way too many hours working out certain problems. So anyway.
Just to piggyback on that a little bit, one thought that came to my mind is it doesn't have to be a single individual. So we can, bring together teams of people. So we have a domain expert who knows a lot about medicine, but not too much about computer science, and put them in the same room with a computer scientist, and good things can happen. And then from the computer science perspective, also, the better job we can do at distilling the data and presenting it in a simple, intuitive, easy to understand way, the more pervasive it will become, I believe.
So briefly about the career paths, the question Lou asked. So obviously, I knew the question is going to come. So sitting there, I looked up on the job website and looked at the various types of positions people ask. And most of them, they relate to data analysts, data scientists, business intelligence analyst, and so on. Obviously, all of them require the core background, the analytics background, and then depending upon the type of industry you're going to work. So the terms are actually different. And one interesting job that was listed is a passport fraud data analyst right in the Boston area. All right. So there are various companies which are interested in hiring the people in these backgrounds. And it's our intention to actually get together to develop the set of courses which will train the people for those specific areas.
One critical application of data analysis is to understand and read the performance of a process or a project or a company. So in my opinion, that's one of the most challenging but also promising area, how to evaluate organizations and or projects based on your reading of the data. So and our challenge and opportunity is teach our students how to do this.
Thank you very much. Do we have any questions from the audience at this point, or online as well? Any questions from the audience? So the question is how specialized the statistic is versus the data mining.
Well, you know, we do have a bit of a problem with definitions, because the term data mining itself means different things to different people. So oftentimes, like for instance, when Ellen was speaking about natural language processing as a text mining tool, well, that's data mining, but you can mine numeric data just as well. So with that in mind, there's a question of application. So IBM's SPSS, for instance, and its competitor SAS and open source R applications all basically do the same thing in a little bit of a different way. But the idea is that in order to use certain type of data for making, let's say, certain types of predictions in different contexts, there are oftentimes different assumptions that the data meets or doesn't meet, which then kind of points us in a direction of different methodologies. So the idea is that, you know, you can't almost do a good job with one without having adequate control or command of the other. So you know, the days when traditional statistics courses were taught, you know, the data was presented as this very simple, you know, we have 200-300 observations from some, you know, almost ridiculously simple survey, and then the focus was all on the methodology. And nowadays, I think the data has to be transformed in so many ways oftentimes, simply because the way it comes out of the machines that capture it is not analysis ready. And so depending on what data you have and depending on what kind of outcome you want to produce, it's going to push you in a direction of different techniques. So you have to understand enough about how to manipulate the data and correct the various challenges that it comes with. And then you also have to understand the statistical methodology. Hence the term data scientist, at least the people I know in the industry, tend to have, say, PhD in statistics and also considerable experience in data manipulation technologies, working with SAS, SPSS, R, and essentially getting data ready for analysis. So that's the point where, you know, you really have to combine the two. Otherwise, you just become a person who prepares data for someone else to analyze. So you're not really a scientist. You're kind of like a data clerk, for lack of a better term.
May I add something there too? I think that's a great point, Andy, in that the term data scientist, although it's becoming the buzzword the same way big data is, there is distinction. And I think the statistics background, the programming background, you start to see this manifesting itself in job postings and things like that, where maybe, you know, some of the data we show says that 40% of some of our ecosystem, for example, are looking for business analysts. The business analysts maybe interpret the data, make decisions on that data, but maybe it takes that data scientist to really bring that forward with a strategy, maybe bring that forward to create those visualizations to allow those business analysts to make the appropriate decisions. So we also see a pattern, what we've been calling T-shaped skills, literally a T, if you will, depth and breadth, that in which you have industry expertise perhaps, maybe you are that programmatic skill set, maybe, for example, 39% of our ecosystem saying they're looking for information specialists and cybersecurity specialists. You can't separate those two topics, right? So you start to see where this coupling of skills, industry skills, data scientist skills, but maybe in the business analyst, you know, it's interpreting that data, understanding the data, deriving meaning behind that data, deriving knowledge from it in the industry context. So whether it be in a technical background, depth and breadth. Business context, depth and breadth as well. And so I think, to Ellen's point, organizations are looking to couple these skills together in a particular role or assembling teams. assembling teams. And I think that's the most important about this, that communication skills, since we're talking about skills, teaming skills, these are also very, very important skills that have nothing to do with the IT technical aspects of this, that are very important for someone working in the field of big data and analytics.
Thank you, Bob. Was a question from another or comment?
So we are talking here about big data.
Information, knowledge. Yep. Yep.
And there is good understanding that the ability to process and just get data is limited by explosive growth. However, I can see that most of projects that fail, they don't fail because of statistics. We have enough statistics. We have enough tools and techniques. It's obvious that most of those projects fail for asking wrong questions. And how do we educate people? Talking about those analysts, but also there is high level of knowledge workers so that we can integrate the whole process. And I think there's definite need in education for going along the pyramid, not only at the bottom level.
Yeah, I think this is a very important point. So being an analyst, it's not one size fits all. It really has to have expertise also in the specific area of interest, because as Andy pointed out, if you're working in healthcare, or you really need to have input and to understand the healthcare data, whether that's images or other type of data or genome, who knows what. But the question is, how is this area specific, and what kind of expertise, what kind of depth do we need in the specific area for the people that work in analytics? In this case, with case of George, we have a computer scientist who is, who has practically, all the expertise in the computer science and works in the marketing department. How can we understand the level of depth that is needed by the industry in specific fields?
Well, if you look at how we taught statistics historically, aside from the fact that we taught it in very on a very limited basis, unless you happen to study statistics, it just was usually one of those bitter pills that one had to take, and you take it once, you get through it, and then you'd never have to deal with it again. And obviously, unfortunately, that for those who felt that way, that is no longer the case. And so, but I mean, realistically, what I think, in order to get to your point, maybe what we should do is start, as opposed to focus on methods first, and then teach those in this kind of an esoteric, abstract, it doesn't really mean anything to anyone. It's yet another branch of mathematics where these ideas that people can't relate to are being forced on them. And start from the other end of the continuum, which is simply to say, here's the business problem. So if I am a marketing manager, I need to understand how to attract more high-value customers. Well, how do I do that? Well, there are ways of doing that using data, using information about your current customers, and so on. And so if we start from that and work backwards, and then say, okay, so what kind of data do we need? And vis-a-vis what do we have? Well, how would we take the data and analyze it in order to answer that basic business question, and then basically back into some, whether it's some kind of a regression or some other type of analysis, then there is a logical progression, and then the analysis of data and statistical techniques become means to an end, as opposed to these yet another example of, the abstraction that one has to learn for no particular reason. And so I think if we do it in that way, it's going to reset the mindset in terms of, what is the analysis of data, and what ultimately what purpose it serves. And that's been, again, my experience of how it can be made, how we can train someone, because I had to do that to younger analysts. How do you teach someone to analyze data so that they're not just crunching numbers for no particular reason, but arriving at answers to specific questions?
Thank you. Any other comments?
I just wanted to add something to your question. You might find the answer you're looking for. So I was reading recently a book by Kaiser Funk called Number Sense. and he uses the term number sense to describe exactly what you're talking about. So, as you pointed out, most analyses do not fail for a lack of statisticians or computer scientists or data. The fact is that we can answer many more questions, and many more questions means many more mistakes in answering the wrong questions, not giving the wrong answers. So developing that skill that he calls number sense seems to be difficult. I don't know how we're going to do it, but maybe you want to take a look. There's some really good insights.
Well, the answer. But I think the fundamental piece of the structuring the whole. And I think the point of also that group of people proper application. Educated times not to speak like never spoke to me.
Okay, any other question from the audience, please? I will just repeat the question. The question is, what are the best business analytics programs and based on this for Bob?
My observation has been the past 5 years, schools of business, marketing programs, schools of business have moved very, very quickly. They've mobilized to evolve, tweak, update their programs to provide masters in business analytics, concentrations, track certificates. RPI, for example, in New York, Torrey, New York, has offered a master's in business analytics, and they offer some pretty nice programs in terms of business intelligence, data mining, predictive analytics capabilities, and they're using some of our tools for that. They also have quite a bit of work going on with our Watson team. So RPI is one of the only universities that has a Watson, a cognitive system environment. And some fairly substantial research efforts going on the way there. University of Virginia, I've also worked with them in the past, so my colleagues cover them now. A really good program in the past 3 or 4 years in terms of McIntyre School. We also have universities on the West Coast, of course. We have Northwestern, for example, DePaul. Fordham University in New York is another school I've worked with a master's in business analytics that cover that whole spectrum of business intelligence, predictive analytics, data mining, text analytics, data warehousing in the School of Business. But most importantly, in the context of solving business problems. And so I think what I see a pattern here with a lot of these schools is that many schools have been rolling out these programs, looking for industry context, providing, to your point, Andy, earlier about hands-on experience with industry tools, not just IBM tools, of course, open source tools, other vendors' tools, because those are the tools that are being used in industry for these marketing programs, or fraud detection, or financial risk analytics with things like algorithmics, now part of IBM. So I think we see a really good pattern here with the business schools mobilizing fairly quickly, as curriculum doesn't change very often. But what it does, we see new programs coming out, new masters in analytics. And those are several of the schools that I'm most familiar with that are getting a lot of recognition. Fortune had an article just a few months ago highlighting some of those, as well as others. And we see now that computer science engineering now doing the same, following suit, sort of updating, like here at BU, updating their programs, maybe emphasizing more areas, like Professor Schuette's courses on advanced data management, and others here at BU that are updating and revamping to provide students a better opportunity and weaving in some of these technologies in the computer science engineering domain. So hopefully that answers your question on some of those areas on the business school aspect of it, MBAs. And there are more coming. More universities are waiting for state review, if you will, and other certifications to make such similar announcements. So thank you for your question. It was a good one.
Okay. Another question from the audience or online? So the question is whether there is going to be a diminishing need for relational databases as we go forward.
Take that one if you'd like. What's happening is a revolution phase. What's some of the things that are happening there? Thank you.
My name is Bob Schutte. I teach advanced database management here at BU. What's happening is a major revolution, the biggest changes in databases since the 1970s. And what's happening, it's the big data push, but also it's object relational and other earlier things like 10 years ago. But what's happening is that the major vendors like Oracle of the relational databases are getting integrations with the big data tools. That's still fairly early. We teach that, for example, in the data warehousing course here, and I teach some in my advanced database management course. It's early, but the relational databases aren't going away. In some ways, their power is being increased by the addition of these not only SQL or NoSQL database constructs, the extensible databases. The major structural difference is that the relational databases move the data to the engine. So you have these data servers and stuff, and then the data gets moved to the processor. These very large databases, it's just not possible to move the data. It takes like weeks to move some of these data sets. So the queries are pushed to the data. That's the MapReduce and variations on that. So these very different paradigms are being married. That will take 10 years, roughly. These are very hard technical problems. But the leverage from that is huge. So for example, the information that you have on your customers is primarily the stuff you know to be good is in your relational database. The tweets, the cell phone localization data and stuff that'll help you target that customer, the very volatile data, the high velocity data, is coming from other sources. So they're very different in veracity in how you treat them. But relational databases will be with us for a good while. Thank you.
Thank you. Another question from the audience? Do we have a way of getting questions online? Or have you heard any? Holly? No, we haven't any questions. I'd like to ask the people who have been dealing with data, how clean are the data? Because usually the data that we get are quite dirty, and there is a lot of work that goes into just preparing the data. And I'd like to hear from George and Suresh and Andre how difficult and how time-consuming is preparing the data, and what part of data analytics is that?
What part of data analytics is that? I don't know that there is a name for it, but certainly it's a large fraction of our time. So there is an ongoing trend where data is not only dirty by accident, but it's obscured on purpose. So you can think of companies like Yelp that I study that are in the business of essentially disseminating information. So they would love their reviews to reach the maximum number of eyeballs. At the same time, it would be very scary for them if someone could easily obtain their database by writing some simple code. So they take measures and countermeasures, and there is an arms race in protecting their proprietary data that at the same time they try to make available. So for us researchers who are generally benevolent, this is a problem, and it takes a large fraction of our time. As a data point, for the work that I presented, I think we spent approximately, let's say, 1 year getting the data, getting it in the right form, figuring everything out before we could start writing the paper. So it's a considerable amount of time, but it pays dividends. That's why.
As part of the curriculum, so most of the data mining classes and data analytics classes will have an explicit focus on the data cleaning part. So obviously the data, depending upon what type of application you are going to deal with, so the data is not going to be clean. And especially if you're talking about the reviews that the user is going to type. So obviously if they're sitting on the desktop and then typing, you can expect a little bit more cleaner version of the comments. But if you're typing with your 2 thumbs on the cell phone, obviously the text is not suitable for our data pre-processing task. So different types of tools, they actually provide the various analyzers to actually look at the data and then make meaningful sense out of those data. So they are part of the curriculum itself, where we explicitly focus on how getting the data is one part. Where are we going to get the data? We assume that we are going to get the data from the trusted sources. But once we get the data, how we process the data and how much noise was introduced in the data. It doesn't have to be the text comments. It could be any measurements through any instruments that we are dealing. If you are consistently seeing something that is going wrong, so we need to find out where the errors are coming from and then rectify those errors. So all those are basically part of the data cleaning process. And most of our courses, they have, at some point we assume that the data is clean and then move on. But when you come to that, prior to coming to that particular process, so there are various techniques that we use to actually clean the data and then process the data.
Now, in terms of industry work that I've been doing over the years, if I had to guesstimate, and it is a guesstimate because I didn't keep track of it, for every hour I spent doing the actual modeling, I had to spend at least 2 hours doing the data cleaning and preparation work. And quite frankly, preparing the data for analysis is far more difficult, largely because there are unexpected and unforeseen challenges, some of which are systemic. So if our data is collected a certain way, then it may need to be restructured. If it's unstructured data, then we need to imbue some sort of a structure into it, whether by means of text mining, extracting some insights that we turn into variables and so on. But even if that's not the case, then there are deficiencies in the data. There are missing values, there are incorrect values, and so forth. So there is no simple solution to any of it. It basically always depends, and so it's time-consuming, and it requires a strong understanding of the data itself, and frankly, it requires some imagination too. And so all of that means that it takes up quite a bit of time, and it takes a fair amount of skill in order to be able to do it correctly. Now, thanks to the tools that we have at our disposal right now, so if it's SPSS, SAS, or all those well-developed, mature statistical analysis packages, the actual analysis takes relatively little time because it's been automated to the point where if you know what selections you're choosing, what you're pointing and clicking on, or put in a short program, well, then it's a fairly quick process. But the data prep can be very, very time-consuming, and that's where real mistakes are made because it's the traditional garbage in, garbage out. And so that's the biggest, I think, challenge, and that's the area that historically we haven't emphasized in our instruction, and we do, frankly, need to do a better job of preparing students to be able to do that better.
I just wanted to add one quick point to that, which is I found that actually the missing data that Andy mentioned is sometimes a big problem and an interesting problem, and it's a little bit of an art in terms of what to do with it. So if it's 0.5% of your total data, you may just throw away those records. They just don't matter. But if it's a significant portion of the data, you may want to choose a model which tolerates missing data. So you might want to build a Maxent model, for example, which can handle those sorts of missing fields. So it's kind of an art. That's where the art comes in.
Thank you. Please.
So my field is in bioinformatics and immunoinformatics. So basically I deal with biological data and immunological data. And data in those fields, mostly there are variety formats of data, and the data quality is also vary a lot. So I would say when I do data analytics in this field, half of my time spent on data cleaning, organizing the data, process the data. So there are tools that we can use to formalize the process, for example, taxonomy, nomenclature, and there is a great need to set up proper nomenclature and proper structure of the data, at least in many fields, not only in biological, also in healthcare. Later I moved into health informatics. So because of the government is injecting $27 billion to promote healthcare IT. So with all this digitalized of our healthcare data, data in all kinds of different formats. So if we want to do analytics on this data, the prerequisite, the first step is to properly organize the data, put them into certain standards, process them into certain standard according to certain taxonomy, certain nomenclature. So it is an important topic in the field. That.
Thank you, Guanglang. Obviously, data preparation is important topic. Data analysis is the second one. And the last one is data visualization, which is essential for presenting the results. And we didn't have a chance to talk about it, but it's a major part, I think, of data science. And but I'd like to, that I'm trying to be aware of the time, and I'd like to end up with a question to ask our panel members. What are the top new areas or new opportunities in data analytics that you see over the next 3 to 5 years? Like some areas that have not been seen. Like recently I saw using analytics in human resources or evaluating nurses, or there are really areas that that we have in education is one thing. We are monitoring our courses, but what are, in your opinion, the areas of growth, the new areas of growth over the next 3 years? Please. Andrew?
Well, one area that has been sort of the holy grail in a lot of industries is that of multi-source analytics. So when you marketing tends to be familiar to most people. So when you think about, I think George, you mentioned someone mentioned 360-degree view of customer, which is what most marketing organizations want to develop. Well, how do you do that? You basically have different data that pertains to different dimensions of consumer behavior that comes from different sources, and it's different in all imaginable ways. But the goal is to ultimately pull it all together into a singular informational reservoir, and in order to and analyze it as all these different data points as sort of attributes of a single customer. In order to do that, all of the data has to be amalgamated together and made into one whole. And then so that it all can be analyzed, so we can see how attitudes, for instance, relate to actual behaviors and so on. So how online behavior relates to offline behavior. And so all of that falls under this one general umbrella of multi-source analytics, which is essentially the skill that it takes to be able to take differently sourced data and mash it together into a singular reservoir that then can be analyzed as one. And virtually in all aspects of industries that I've worked on, that is something that is of great importance.
One of the largest consulting company in the world is in Boston. It's called Bain Company. And they are publishing every year a list with areas where analytical tools are extremely important. And in the last 3 years, human resource is one of the top 3 all the time. And the trend is that the future companies will search for talent and will reverse the current process that you are applying for a job. They will ask you to join the company based on information about you as a candidate. Another very important area is risk assessment. The enterprise risk management is becoming a very powerful area where risk is not a catastrophe-related event, but opportunity, and how to assess and organize the life of the corporation based on all these new reading of the data is the challenge, but also opportunity for the industry.
Thank you, Vladi. Any other areas or that?
Thank you. I started my talk earlier about just talking about the convergence that we're seeing, the convergence between data as that natural resource, cloud computing, the ability to not only consume IT services, but deliver IT services. And the third area is really what we're calling systems of engagement. That is, taking advantage of and leveraging the 1 trillion devices, the rise of mobile, the rise of social business, social networking, where we're seeing a lot of interest and a lot of inquiries and probably investment. If you look at IDC data, 30% growth of big data on software and services, it's really exposing where there is a shortage of this big data and IT skills as it relates to big data, cloud computing, and mobile. And so security is that one of those areas that really brings all that together. So I think we see a lot of organizations really trying to understand how to best govern, leverage cloud infrastructures, hybrid platform as a service, infrastructure service, as relates to data and security. Having it being built and managed and governed. And so we see a lot of investment in that cybersecurity, cloud, and data. It's really the convergence of those three areas that organizations are really, really looking to bring new talent, but also continue to innovate.
I think this is a very good point, especially when we talk about the Internet of Things, and the other part of the equation, which is privacy, that will be, and it is already an essential part of data analytics. There was a question from the audience. Yeah, so let me just repeat the question. The question is, if you have a computer science degree, what kind of specialty you need in the specific area to find a job, which is related to the career path. So anybody from the panel? This is related to the questions that we addressed. What kind of expertise do you need in a specific area? And the trend that we were seeing earlier, like financial industry was hiring a lot of physicists traditionally, people, they were basically doing analytics and modeling. But so when instead of doing a lot of postdocs, they will go into finance industry and make money. So the similar was the trend in the other industries. But I think that with healthcare, we see that health informatics is becoming very clearly defined discipline, when you need to know the medical terminology, you need to know the systems that are being used, especially for electronic medical records. So it really depends on the area, and from what I see, it has to be more specialized. George,
I think it has not changed much from what you described in the following sense. My experience is that there is tremendous demand. I think the students here at BU for those with computational skills. And there is no need for hardcore specialization, because in my experience, in many cases, large companies at least have the resources to provide that training to their employees. So if you go and work for the Googles and the Microsofts and the Apples of the world, I think they would rather train you. So even an undergrad computer science degree, I think, remains immensely valuable. That's my experience.
What I would suggest, again, based on my own experience, is skills and tools. I mean, imagine if you go on a job interview, if I sit across the table from you, it is very difficult for me to discern whether or not you have the capability to learn, because of just, it's hard to assess idea. Now, it is fairly easy for me to determine if you have the right skill sets, and if you are familiar and have some fluency in the basic tools. So if you want to be a data analyst, and I want to know, have you done that kind of work? Are you familiar with, at least have rudimentary understanding of SAS, SPSS, or those kinds of tools? Because organizations right now depend on people doing work that way. And so, when the choice comes to someone who walks in the door and says, I have done this work, I have at least rudimentary understanding and hands-on knowledge of those tools, and I have these kinds of skills of, I've manipulated these kinds of data, I did those specific activities. That's one way to distinguish yourself and get a leg up on the competition. And generally speaking, people like that will win over, because if I'm your manager, last thing I want to do is spend half of my time training you, because that means I have to work 50% more time. And if I'm selfish, I don't want to do that. And most people, unfortunately, are selfish. And as far as the degree, I would suggest get a job first and figure out what is it that you really want to do, so you can choose wisely when it comes to the next stage of your education. Because sometimes things look one way. Once you get into that area, you realize, that's not quite what I thought it was going to be like, and then you may want to make a switch. And so once you find a place that you're comfortable in terms of the type of work, then that should direct your next educational endeavor, I would think.
At this point, I'd like just to summarize with things that no matter what you decide, you will have to plan on continuing to learn as you go. And that's what I think it's a must from what we see. So many of these areas were just not there 10 or 20 years ago, or even 5 years ago. So continuous learning is really a must. I'd like to, and this is a very nice introduction into our next panel, which will focus on the educational programs in analytics. So at this point, I'd like to thank our panel members for participation, and I'd like to, if you have any questions for them, maybe you can catch them later. But at this point, we can have a very short break and then continue with the next panel on education. Thank you. So our second panel is devoted to developing data analytics curriculum. And here we have experts from our computer science department, and they will be ready to answer questions. But I'd like first to start with a brief introduction and a statement about specific areas of involvement in data analytics. So, Bob, please.
I'll try to be brief.
I've done research in natural language understanding, hydroacoustic analytics. I've a number of years at the Analytic Sciences Corporation. And I've been leading the activities here college-wide to develop analytics within Metropolitan College, and also building liaisons with other schools that have strength in this area across the university. So some of the major results from that are that we're clearly short of resources. This is a very large area. And so we're developing a curriculum which combines courses which cover many disciplines. And we have 3 courses under development and 2 existing courses in that area. And combining those with discipline-specific courses from different departments, primarily in the college. So that we're putting together now curricula at the college level and across the university. It's really exciting stuff. So,
thank you, Bob. Anatoly?
My name is Anatoly Temkin. I'm at the computer science department, Met Computer Science. I'm the department chair. And I've been teaching for 2 centuries. So essentially, I've been around for as long as BU was around. We've just come up with a curriculum for concentration in analytics. So we have developed 4 courses. Well, what I really want to say essentially is that The way I see data analytics is, I mean, a person who wants to be successful in research or just work in analytics is somebody who knows probability / statistics and computer science. Those two things, put together, resulted in what's nowadays is analytics. And the knowledge of, and actually not even the knowledge, but the understanding of applicability of statistics is vitally important, because with all of the packages and everything, people who use those packages without understanding what they're doing, they are dangerous people. So by having said that, I'm moving on.
Thank you, Anatoly.
Okay, yeah, thank you. My name is Jae Young Lee, and then I'm in the computer science department. And then my research area is primarily data mining, and then that's the context how I get involved in the development of analytics curricula.
Thank you.
Hi, good afternoon. My name is Guanglan Zhang. I also work at Computer Science Department at Metropolitan College BU. So I'm pretty new to the department. I joined department in 2012. Before that, I was working in Dana-Farber Cancer Institute and also institute in Singapore, primarily in bioinformatics and immunoinformatics field. And at Computer Science Department, I'm teaching and coordinating health informatics programs. So as we already heard several times, that analytic skills is required nearly in every industry and also in biology and healthcare. So I think to be successful in this field, we need some kind of domain knowledge plus the analytic skills.
Thank you, Guanglan. Vladimir?
I'm Vladimir Brusic, and I am Director of Bioinformatics at Cancer Vaccine Center in Dana-Farber Cancer Institute. I'm also Professor of Computer Science at Metropolitan College. And my interest in analytics goes a long way back to 1980s, where I was doing mathematical modeling of biological systems. And to do mathematical modeling, you need all kinds of data, different types of data, so that the system is modeled. And then you use behavior of that model to predict. So predictive analytics involves mathematical modeling, for example. And building right models is the key for success there. And also what we do, and what is very important activity, curricular activity at MET, is that we are working on optimization of multiple requirements for developing curricula. And I think we'll be talking more about that in the panel. Just to start, we have to harmonize requirements from the government, because government has a lot of say in healthcare reform, for example. We have to address accreditation of the courses so that the standards are established. We need to address industry needs, because students need to be trained for the jobs rather than trained on the jobs. This is what BU wants to distinguish our courses compared to other schools. And then we also need to maintain academic excellence and optimize use of our resources. And all these factors have to be considered when we build curricula.
Thank you. Question that I have for the panel is, what are the main components, courses, areas, and concentrations of a graduate level data analytics curriculum? So let's go into details, and let's start with the areas that need to be covered in a well-designed graduate level curriculum. Bob, would you like to start?
Yes, the areas that we need to cover and the areas that we're planning on covering fairly soon, and the areas that we do have coverage already. We have strong courses in data warehousing, which includes data cleansing and the data harmonization. There's some seemingly ordinary problems like, hey, is that tweet from my customer? Those are critical, hard problems that people have to solve routinely. And it's really, really important. So those kinds of things. We also have very strong courses in data mining and also in the data warehouse and advanced database technology for big data databases. We have those areas very well covered. We don't have coverage, I list the one area where we really don't, and that's in natural language processing. I've done research in that, but I can't take on everything, so I'm not going to, and I'm also, my research was years ago. So some of the areas that we do have under development right now is data analysis and visualization. These are courses approved at the departmental level, going now to the college level, and concentrations in data analysis as part of a Master's of Science in Computer Information Systems. That's something, the T, as Bob was talking about, which provides the breadth across all of the information technologies areas in a very strong program, award-winning program, together with depth in the analytic areas. That also raises the key problem. How do you produce a good curriculum like this without having 15 courses in it? We try to keep it to 10 or 12 at the most. That's a major challenge. So we have ongoing discussions in the department and more broadly to find ways of getting the depth and still the breadth in these different areas in a reasonable sized curriculum. It doesn't matter if you have a world-class curriculum and those students want to come because they have to take 20 courses. So those are the challenges, to make it efficient for the students. So.
Well, we have the first course we want our students to take is Foundations of Analytics that deals with statistics and the probability theory, because that will build the basis for any future learning, and also R as a tool will be introduced. One of the biggest problems that anyone can have when dealing with any curriculum is to figure out what is that manageable range of subjects, that should be covered, because the field of data analytics is enormous. And the purpose of our curriculum is to make it possible for students upon their graduation to be able to work independently. Of course, there is no way for them to learn everything, it's impossible, but if they have the right foundation, they will be able to do that.
Oh, actually, so I don't think I have anything else to add. And just one more thing. So one of the topics which I think is important in analytics area is that the analysis of, people call it link analysis or network analysis. These days, there's a lot of things, information, people, organizations, and then if there are certain patterns, probably it will be very beneficial to identify and then use those patterns.
I want to put some emphasis on changing education in this field, because traditional model was that, let's say, we teach tools. How do we apply different tools? So we teach students a set of tools, give their characteristics, then go to laboratory, give several examples where students can do it, and then give them an assignment in which they're supposed to apply this. This doesn't work today anymore because the range of the available tools is very broad. And we cannot in 40 hours that we have in the course, we can cover all of those things. So the emphasis is moving from understanding and repeating what was taught in the class into problem solving. So students, rather than being focused on knowing all 10 tools or 100 tools or 1,000 tools which are available, which is impossible, they're asked to solve a particular problem and find appropriate tools, then analyze these tools. So we have to enable people rather to learn by problem solving and addressing the real life issues rather than those standard examples that have been taught in previous times.
And this is a very good point that Vladimir is making. Very often in our classes, even graduate classes, students will ask, so you didn't tell me what I should do here. Yes, you just asked me for a solution. And that's exactly, you have to find a way how to find the solution or appropriate tool. That is part of the assignment, finding a tool, finding a way, because there is more than one path to the solution. And it's not just applying a formula as and at the undergraduate level you would be. But even at the undergraduate, I don't see. Do you think that there is a opportunity for data analytics at the undergraduate level as we go forward? Do you think that in certain areas, people even at the undergraduate level would have interest or need for data analytics, or this is strictly a graduate level discipline?
I have opinions on many things.
I'm really reluctant to say we should graduate someone with a bachelor's of science in computer science without having a substantial analytics piece, like a course level, and it could be a part of another course, but they need to know about this stuff. It's much of what computer scientists do today. It's about half of what IT professionals do. And to talk about the little thing about the other thing about the topic of problems, I require in all of my graduate classes that the students identify a real research problem and work it through to the conclusion at the end of the course. So the students get not only toy problems, the ones they can solve in a week or something, but problems they work on all semester, often with a lot of involvement of their faculty, to be able to work them through, not real master's level problems.
I think also it's important, thank you, Bob. I think it's important also to leave the door open for career changers, because this is very important area, a growing area that I think that we will see more and more people changing their careers into data analytics. And so not everybody will have a background or undergraduate degree in computer science, but there is a set of courses, set of skills that can be developed, prerequisites basically, that can make them employable and trainable into the area of data analytics. I think that that's very important.
So important issue that we have here, and we have to be flexible about that, is that we have changing student population. It includes career changes, but it also includes that different people from different backgrounds are coming into our courses, because computer science and information science is being applied across the board. It's present in all industries. And normally, I'm not known as somebody who has radical views. I think about it because I analyze data, so we need to have to see it from different angles before we make our conclusions. But in this case, I'm getting a radical view about data analytics, because all these basic techniques, the approaches are becoming a literacy for 21st century. And what I think is answering to your question, is it important for undergraduate studies? I think it is important that those basic courses that can be applied across different disciplines are essential for undergraduate curricula, so that people who come to master's level course or go to PhD, they already know the basics of the fundamentals.
Yes, this is one of the IT areas, becoming one of the IT areas that is essential, similar to security and the other. Also, if we want to say even management or financial knowledge is becoming one of those areas that are really a necessity for anybody who will work in the industry. Any questions from the audience at this point for our panel? Please.
I worked a lot in retail as far as inventory management. A lot of the parties, they don't require graduate level programs to go. And they don't have a background in analytics. A lot of times when they do forecasting, they rely on the tool, and basically they drive their car into a river. They don't really question, work that into kind of build that background.
I think the comment, just for our people online who maybe couldn't hear well, the comment was that you just cannot rely on the tools. You have to understand how the tools are being used and what are the data that they base their decision on. That is extremely important point that was made several times, I think. Any other question or comment from the audience? Please. let me repeat the question. Can you start or can you base your career on data cleaning and data preparation? And what do you need to start your career in that area? What is the niche?
Definitely. Many of my students have their careers in that area. So it depends. If you're doing data cleansing for the relational model, that's all you need to understand is the relational model. You don't understand it well, and the various techniques and some of the emerging tools for cleansing data. There's a whole explosion in the commercial space. Join an organization at the Data Warehousing Institute if you're not already a member, and you'll get the feeds from them. It's tdwi.org. And you'll get the feeds from them, including the market information from all the vendors who are participating in this space. You need to learn those tools to a certain level. You need to learn some of the techniques. They're not only mathematical, they're mining techniques, data mining techniques for it as well. Things like outlier analysis, cluster analysis. Much of what Andrew talked about in the previous panel is heavily statistical. He's done statistical analytics, but not the artificial intelligence-based techniques. And many of the cleansing techniques are not statistical, but AI-based. So you need to learn some of both of those. Again, there's support in the tools. We have courses in all of those areas as well to get you ready on that. But it's a major area in which there are, of the order of 100,000 unfilled jobs. To put it in perspective, if you're building a data warehouse, and I worked for the leading data warehouse firm in the Boston area, we budgeted 70% of the cost of building a data warehouse was for data cleansing. It's huge.
And the question was also, what kind of background would you need for that? Probably not the same set of skills that you will need for data analysis, but you will definitely need quantitative skills. You will need to do interpolation, extrapolation techniques, to understand biases in the sampling, to understand the sample size, and many other things that are connected directly to the data, so that people who will get this data, they know how they can use it in the best way. But it's definitely a large, more than 0.5% of the resources are dedicated to data preparation, cleaning, and cleansing in general. So I think definitely it's an area.
There's been a major change in the last 5 years in that area that's largely complete now. Remember, Ellen talked earlier about extract, transform, and load. That doesn't work very well anymore. Now it's extract, load, and transform. You load the data maybe into Hadoop, it may be into your data warehouse, and do the cleansing there where you have the extraordinary resources of the warehouse, whatever technology it's built. So you need to learn those techniques as well. If you're doing cleansing of structured data, it's sufficient to learn the relational and object relational models well. If you want to do cleansing of unstructured data, you have quite a bit more to learn in the natural language and unstructured data techniques. Again, we have courses.
And very often this will be done remotely. If there are large big data databases, you will not be able to extract them and move them to your computer. You will have to do it on the cloud, and all the processing will have to be done remotely. So there are really techniques that are dictated by the demand of the data size as well. Guanlang?
So I'll say something related to data cleaning. So for example, in healthcare, in health informatics field, there is a fast-growing position called medical coder. So basically they translate unstructured data, for example, physician notes, into structured data according to some type of data standard. They basically code the unstructured data to structured data. So it's also a data preparation, not so much cleaning, but preparation. So medical coder is a fast-growing demand in healthcare.
And I think, Guanlang, related to what your point that you're making, there's also a need of educating medical experts, physicians or nurses, in how to use medical data. So, and how to analyze them, and how to get trained into that.
Yeah.
Because as you know from experience, many physicians or nurses have very rudimental knowledge about data processing, data flow, and computer science techniques in general.
Yeah, that's why we have medical coders, so that physicians don't need to worry about this problem. Medical coder translate the physician notes into structured data. Actually, we have an example. One of the students in our health informatics program, his background is pharmacist. So he's a pharmacist. So he has a domain knowledge. And after he took the health informatics courses, he changed job to health informatics related position. Basically, what he needs to do is he read those medical notes and translate them into certain type of structured data. So.
Thank you. A question, Bob?
We've talked a lot about curriculum. Vladimir, you mentioned I'm wondering if you could make comments about, since curriculum is evolving to respond to needs in the marketplace, to help students create opportunities, what are the building blocks? Talk about the differences between your focus on undergraduate programs, graduate programs, as different ways in which the concentrations and tracks, and how students can seek such opportunities or take advantage of the curriculum.
Yeah.
Can you just repeat the question?
So the question is, because we have changing student population, how do we address the issue in developing curriculum so that diverse types of students can be served by our teaching? And I would add to that also that technological environment is changing. Our students don't study anymore in the classroom exclusively. We have classroom, but our classrooms are also electronic. And I know that quite a big proportion of my students, they actually study on the train, in transport. They study when they travel overseas, and they use a lot of mobile technology already. And one of the challenges is that when we have group projects of those students, they're at different places and they access the project place, virtual project place, through different means, through iPhones, through computers, or they can sometimes be in the classrooms. So we have completely changing environment where studies are 24 hours. We enable students to study at their own time. Lectures are recorded. Materials are posted online, and the documents are exchanged. All those technologies are available, and students actually learn seamlessly. They're exposed to that in the classrooms, which are now virtual. If somebody misses the classroom, they don't need to take notes anymore. They need to know how to access materials, which are already available.
The logical consequence of the fact that students are learning 24 hours is that faculty are teaching 24 hours these days. So you're expected to answer online questions, and it's really quite a different process than it used to be in the past, having 2 lectures just during the week or a single lecture. And we really see the dynamics, and I think it's to the benefit of students and also of us, because as a faculty, digital learning has penetrated and changed the way we do higher education.
So that's one aspect, and the second aspect is that in our classes for health informatics, as Guang Lan mentioned, we have a diverse population. So some people are trained as computer scientists or information scientists. They have very strong technical knowledge. They can program. But we have people also who come from medical field. Some of them can program, but this is self-taught programming, and it's equivalent to what we used to call spaghetti programming in olden days. And they need to basically be directed about what it means to use proper practices. And in one case, I had a medical doctor, very, very smart, very enthusiastic, hardworking. He was trying to program, and we came to him and say, we thought about his career options, and we advised him to take more courses and get standard standardized knowledge, something. And after taking 2 additional courses, the whole world opened for him. So what we need not only to design curricula for students and groups of students, but they should be flexible to address individual needs.
One of the things that we've done specifically to address this issue of career changers, people who don't have a strong technical background, is to develop a course, CS 200, Fundamentals of Information Technology, which includes 14 weeks of analytics and probability and stuff and mathematics, database, introductory database, data management, networking, and 7 weeks of programming, introductory Java programming. So when the students, no matter where they come from, the ones who finish that course successfully, we find that basically all of them succeed in graduate studies. And so we've developed that course and been tuning it over 5 years. So it's specific things were done. This foundations course that Anatoly mentioned is another course designed partly to meet the needs of career changers, people without a strong technical background.
Thank you, Bob. I'd like to ask a question that is probably very relevant for our people that are following this online. What are the challenges of teaching analytics online? And especially when we have these tools and when we don't have traditional labs that are face-to-face, but are there any specific challenges when we talk about teaching online data analytics? What do you think? Bob is director of our online program as well.
Perhaps I know too well. One of the problems that we don't have a good solution for is realistic size big data databases. They're hard to move around. You can't send them over the networks. I have some of a few terabyte size and stuff, and they won't fit on DVDs even of the realistic size. So we try to get realistic big data analytics into an online format. It's difficult. We do have servers, and we're building up our own cloud to do that. But that's largely an open problem for us, is the data sets. The students can install the tools just fine and use them, but the data sets is a big problem.
We've have some experience with the virtual machines and other issues. But any other program-specific challenges that you see when we talk about data analytics, and especially, as Bob said, big data analytics?
So many analytics courses are already offered by Udacity and Coursera, and then so I don't think there is any issues. I mean, so there might be some technical issues that needs to be resolved, some financial support from the university. I think that's it. So they are doing the same thing. So I think we should be able to do that.
Well,
in general, teaching online class is different from on-campus class. This is not only in data analytics, it's in general the format. I find in on-campus class you meet students every week and you have personal interactions, but with online class you don't really see the students, and they're from everywhere, from different states, even from other countries with time difference, and you don't have that kind of personal connection. They don't see you, they see you from time to time from the camera. So I think the problem is we need to try harder to have some connection with the student. It's different.
Right, but you don't see this as a discipline specific?
No,
issue.
it's in general.
What I find also is that there are different student population, because larger number of online students are people who are very busy and they take online courses because they have full-time jobs, families, and larger percentage of them are already accomplished in their field, people who want to upgrade their degree, formal academic degree, but they tend to have a lot of practical experience as well. So again, we have this group of people who are practitioners and we are teaching them fundamentals, and typically they find it very useful because it enables them to consolidate their knowledge. But the consequence of that is that we have to be flexible about designing the course based on the student population in a particular class. And one of the methods that we are using is that we split students in bigger classes into groups that have different needs, and then address them separately. So even the same course may be taught slightly different depending on the needs of the group.
One of the ways we use this facilitated group model for online, and we haven't used it much on campus, but is to have specialists in the different tools. These are very senior people who know the different databases. It's been very successful. We support IBM's DB2, Oracle, and Microsoft SQL Server in our database courses fairly completely. And we hope to do the same thing in our analytics courses. So if we have somebody who works in an industry where a particular tool is all that's used, we can have assignments for them. That's a lot of extra work for the faculty to produce versions of the assignments that are appropriately designed for the different tools, but that's in our plan. So the courses are hands-on day one, and particularly for online, when we get enough enrollments to have the different facilitators who are expert in the different tools, that we can have groups for the different tools.
Thank you. Any question from the audience? Comment?
An observation that courses, and we've been having guest lectures coming from other faculty, something that we can do really well here.
Thank you. Any other comment or question? I have a question. What are the new concentrations that you see in data analytics over the next 3 years or 5 years? What are the existing ones, and what are the new, basically the new possibilities? Yes. Sorry for the tough question.
Oh, that's good.
We'll certainly have a technically oriented one. It's along the approval process right now. We have the courses under development in the computer science department. There's very clearly a need for one in the administrative sciences department for having analytics focused on management. It's both strong technically and particularly things like how do you supervise, how do you manage analytics projects? They're different. And how do you hire analytics people? All the issues that are specific to analytics programs. That's clearly. We also have, I think, one coming in actuarial sciences. We've had actuaries come to us saying, you know, I've been interviewing, these are people at master's level, passed all the exams and everything else, but the insurance companies want me to know R and deeper analytics, predictive analytics. So there's a need there. It's very clear. Again, perhaps in healthcare analytics as well. Those are the ones that I've seen enough of the need and the course structure to see that they're coming.
We forgot to mention financial analytics. That's where the money is.
Yes. What about visualization? That is an area that I think it will be of interest to be developed. And do you see this as a concentration in data analytics?
In the data analytics concentration we are developing right now, we do have a course called Data Analytics and Visualization. So basically we focus on R language and try to teach different analytics methods plus how to visualize the results. So that's the course right now. But down the road, maybe we can add more visualization component. It's a very important part of data analytics.
And this question relates to question: do we want to train generalists, so people who can go across different fields and deploy their knowledge, or we want to train specialists, people who will go in depth and be analysts in a particular domain field? And I think there is a need for both. And to me, it seems that those who are generalist, the percentage would be smaller than 50%, because these people, that trains people who will eventually go into different fields of application, but there are also specific needs for rapidly growing field, like health informatics and health analytics. The whole field is about 20%, almost 20% of GDP of United States. And the cost of healthcare in United States is double as compared to other OECD countries, which means that if we can save 5% in healthcare costs, the net result will be 1% growth of GDP. This is enormous. And so there is direct need for people who can do and help that and help the reform of the healthcare system as well. And the slow progress into this reform is partially due of a lack of the people who can enable this thing to happen. And I think this is one of the biggest opportunities. So all these big service fields, healthcare, finances, security, and many different fields need that. So I think we need to think about how can we make a proper mix of skills which is needed for the very diverse market.
Thank you, Vladimir. I think the most important thing, whether the graduates will be specialists or generalists, is to learn how to learn and how to continue learning, because it's more than clear that that is going to be a lifelong process that all of us are going to be engaged and are engaged.
I've been attending a number of hackathons in the Boston area. A lot of energy that comes in. Big data transportation hackathons, big health hackathons. I'd love to see the concept of hackathon built into our curriculum as an interdisciplinary activity for advanced students to actually come together, perhaps over a weekend, and look at some interesting problems guided by some.
It's a great idea.
Okay. On this note, I would like to thank our panelists and thank our audience as well, and to invite you to a reception that we are going to have in the hall. Thank you again for attending the symposium. Our audience online as well.